Welcome to the Ultimate Smart Contract course. This is a beginner-friendly course where you will learn everything you need to know about building smart contracts for NFT projects. First, you will create the ERC-721 smart contract like the Bored Ape. Second, you will create the ERC-1155 smart contract like the Adidas Originals. Third, you will create the ERC-721A smart contract that was built by the Azuki team to save you thousands on gas fees. In these smart contracts, you will build the mint functionality, the allowlist mint functionality with different price points. You will add a payment splitter to split your revenue amongst your whole team, and we will deploy your smart contracts to the Goerli test network. But that's not all. I will show you how to use AI to create your own NFT images, combine them with metadata, and upload them to IPFS so you can view them on OpenSea. Last but not least, you will create your own ERC20 CryptoCoin and give it liquidity with PancakeSwap so that your users can buy and sell your own CryptoCoin. Finally, I want to show you how to make your own NFT staking contract so you can reward your community for staking and holding your NFT. Let's get into it. Now, if you want to binge watch this like Netflix and keep track of your progress, I have decided to package all of this up into an amazing free course. All you have to do is click the link down in the description, sign up, and you'll have access to a completely free course where you will see step-by-step videos. You can keep track of your progress, and it will be a much better experience for you. Other than that, let's get back to the video. Let's build the ERC-721 smart contract. In this contract, we will build the public mint functionality. We will add a requirement for payment. We will add a supply limit so only a certain amount of NFTs can be sold. That's right. Finally, we're gonna create the allowlist mint functionality to allow only certain people to mint your NFT. At that point, we're gonna clean up the code, make it all look very nice. And finally, we're going to create a withdraw function so that you can withdraw the money in the smart contract into your own wallet. Anyways, let's get into it. Let's get started right away. So what you guys need to do is you guys need to go ahead and open up remix.ide. So remix.ide. This is where we will be coding our smart contract, okay? Remix.ide, here it is. It's remixproject.org, actually. And then from there, what you want to do is simply just, let me go ahead and make this a little bit smaller so you guys can see my, there we go. Beautiful. Then from there, we will go ahead and hit Remix IDE. I have a few things here. And then Remix IDE, you probably have to log in. I'm not really sure if you need to log in or sign up. But when you get to this page right here, all you gotta do is hit plus, and let's go and just create our smart contract, right? So we'll go ahead and say ERC-721 smart contract. We'll make this into a YouTube, hit okay. So that creates yourself a new workspace, and all I did was I clicked this plus button, guys. I'm gonna go and make this a little bit bigger so you guys can see a little bit better, probably. Now, you've got three options. You've got your contract. This is where you create your contracts. You've got your scripts, and you've got your tests. The one main thing we're gonna be focusing on is the contracts section. So let's go to the contract section, hit new file on this one. And then for the contract, let's go ahead and call this Web3 Builders. That's going to be the contract that I want to create. That's the builders.sol. Web3 Builders, that's going to be my ERC-721 smart contract. Now, from there, once we have done that, now it's pretty empty, of course. We don't have any smart contract whatsoever. To build this out, we're going to use something called an OpenZeppelin smart contract wizard. So let's go ahead and open Zeppelin smart contract wizard, like so. Boom. And you will be taken to this contract wizard. And this is how actually I start a lot of my NFT projects. Whenever we build NFT projects, I go to this. Of course, I also have my template. Now we built out the template at this point, but I start with this, and then I go to ERC-721, and I kind of check things that I need. The most important thing I need is we need to name it. So make sure you select ERC-721. Let's go and name this. It's going to be my Web3 builders, like so. Beautiful. Awesome. And the symbol. So it's kind of like your ticker symbol, almost like a stock ticker symbol, if you want to think about it. So I'm going to call this Web3. Why not? WE3, like so. Base URI is actually the link to the images. So it's your IPFS images. So if you want to think about your base URI, I'm going to hit OpenSea. I just want to show you exactly what I mean by that. So you guys know exactly what I'm talking about. If you go to OpenSea, let's just say you go to, I don't know, any project. Let's just say we go to a project, let's just say the other deed from the other side, which is, by the way, is a great project. If you go to their project and if you look at their actual details here, if you click on this token ID section, see, their base URI is actually this API on the other side, the XYZ. You see this? That's their base URI. If you go to, for example, like Bored Ape Yacht Club, okay? And if you click on a Bored Ape, for example, and then you go to details here section, if you click on the token ID, you can see their base URI is this IPFS URI. You see this? Without the 326. Their base URI is this. That's almost like, think of it as their folder. It's which folder are their images stored, right? So we need to know that as well. That's really important. Let's go ahead. The base URI I have for you guys is going to be this one. I have it actually in the description below. So you guys can actually just go ahead and click on description below, and then the base URI is actually in there. So once you got that base URI from a description, just paste it in directly into here. And this is images already just created, you know, it's like doodles images, you know, so you can just test it out with that. Next thing we will enable the mintable. So we want to make sure we can mint the auto increment IDs, because of course, as we know, when you look at an NFT project, you have these IDs. These are really important. And they are automatically incremented from 0 to, let's just say, 10,000. And so we need to make sure we auto increment that as you mint the NFT. Beautiful. We don't burnable, not necessary. Pausable, maybe. Enumerable, yes, for sure. URI storage, not necessarily for us, for example. We can make it pausable, all that stuff. I think the URI storage is not allows updating token URIs for individual token ID. We don't need that, no. Pausable will allow you to actually pause a contract. Let's just say you want to pause the mint. That could be actually very, very, very useful. And then enumerable is going to allow us to keep track of how many NFTs have been minted so far. So enumerable is what tells you, hey, how many NFTs do we have? And that's going to be really, really helpful for us later on when you want to limit the supply of NFTs later on. So we've got that. Now, all you got to do at this point, guys, is just copy all this, like literally from the bottom to the top. Copy all of this, copy this whole thing. Of course, it's MIT license. And then once you copy that, go back to your remix and then paste this. And now you're like, no, but we just we just copied the whole contract. What the hell? That's all we could do. Just copy and paste. No. So there's a lot more to this, of course. You know, we use this as our standard, guys. These are our standards. It's almost like you're creating, you know how when you build a house, there are standards for how you build a house. You lay down the foundation. That's what we just did in this kind of like with this Open Zeppelin wizard. But moving forward, we need to add now custom functionality. So the first thing we need to add, of course, if you look at this safe mint right here functionality, which is really, really important. Let's look at what's going on in this minting functionality. Well, we have this address too. It's like, who are you minting to? We've got this token ID counter, and this keeps track of how many token IDs, you know. It's like, first we start with 0, then it goes to 1, then 2, then 3, and so on. Really, really important. This right here is the actual function that mints the token. The actual part that mints the token, mints this token that we got, the token ID, to who, which is to whose address. In my case, I have my MetaMask, and this is going to be towards my address. So that's kind of where we would mint. Now, the one thing we need to remove is, you can see this something says public only owner. What that means, guys, is that means that only the owner of this contract can mint the NFT. And that's not very useful for us. That's not very, very useful for us. So we're going to remove this only owner section because, you know, we want the public to mint this. We're going to remove this only owner, and we're going to call this safe mint. Instead of that, I'm going to call this a public mint, because we're going to have two different mints, public and allow list mint. Public mint right there. Beautiful. We got the public mint. Now, the next thing is this address too. We don't need to specify who we're directly minting to, because here's why. What we can actually do is we can use something called message.sender. Message.sender that will allow us to actually get who's the minter. So this address to is something you will pass into a function, but we don't need that anymore. We can actually just get this directly from MetaMask. So whenever you mint with MetaMask, which is what normally people would do, the actual wallet address, which is what this is, the account on the top, is going to be passed in directly through this message object, and the sender is the wallet address. And so now this is going to be the address right here, this one, and the token ID, again, still stays the same. Beautiful. Now, let's talk about how do we make it payable. So let's go ahead and inside here, you know, add payment. That's going to be our next functionality we need to add. So add payment to this. Is how do we require payment for this NFT? How do we require payment? Well, let's take a look at this. In order to require payment, the first thing we got to do, guys, we need to make this payable. And this payable, what this does is this says, okay, this function, public mint, will allow us to do payment and allow us to accept money. So that's what this payable function is for. Next thing what you want to do is you want to require a payment. You think about, okay, how much I want to require per NFT. In my case, I'm going to create a require statement. And this is how you would require something. So you require a condition to be true, basically. In my case, I'm going to say require, let me see, require message.value. That's where we get the money. I'm going to show you what I mean by that later on. Is equal to, let's just say 0.01 ether. This is really, really important, by the way, guys. This 0.0 not enough funds. That's basically, hey, if this is not true, we will send this error, and of course, everything will break. Basically, if this is false, it all breaks here, and then it will not continue to mint. That's kind of how these things work. So we can actually test this out right now to see how does it work? How do we actually mint? Got the payable. That seems to be working. All is good. So in order to deploy this, to test this out, all you got to do, guys, is go to your the compiler section. Make sure you compile your webtables.sol. That's probably already compiled at this point. Make sure you have no errors inside here. Really, really important. Now, hopefully you guys can see my code pretty well. And then to deploy, all you got to do is hit deploy. We can just deploy simply with your Remix like the environment that comes directly with Remix, which is fine. I will hit deploy. Make sure to select the webtables.sol right here and then hit deploy. Now let's see what happens. Boom. So it deployed the smart contract, didn't deploy in a test node, but deployed in their private blockchain. We see that we have a public mint. Of course, we have a pause function, a transfer, a name, an owner, everything. This is directly coming from the ERC, guys, 721 smart contract, by the way. All these functionalities we have imported from these smart contracts. That's where they are coming from. The main one we created was the public mint. So let's try to mint an NFT right now. If I just simply said, hey, public mint, well, it's going to give me an error. The first error it's going to give me is what? Not enough funds right here. So not enough funds in terms of we didn't pass any money. So to pass in money through Remix right now, because that's how we test our contract, we're going to pass it in through this thing right here, through this thing. So in order to get that, we need to put in a value. So if I try to put in, like, for example, ether, let's just say we need to pass in 0.01 ether, correct? Where's our, right there, 0.01 ether. So if I try to type in 0.01 ether, it doesn't let me type because it only needs integers. That's right, integers, okay? So what we need to do is to convert this ether to GUI. Check this out. I'm gonna say here, GUI converter, boom, Ethereum unit converter, really, really useful. I use it all the time. And convert 0.01 ether to GUI right there. So if you're thinking about what is GUI, basically think of it as ether is like meters, GUI is like centimeters, WEI is like millimeters. Got it? So it's basically just a unit of measurement. I'm European, so that's why I use the meters and centimeters. So basically this is the exact same amount as this, it's just that it's in a different unit of measurement, almost like inches and feet. There we go. So this would be feet, this would be inches pretty much. So we're gonna get this. That is what our 0.01 ether is. I'm gonna go back to our Remix, and then I'm gonna type this in right here. Boom. So we're gonna pass this in, and now if I hit public mint, check this out right here. Boom. You can see it minted an NFT for me right here. A minted NFT of ID of actually, I believe it's an ID of 0 right here. An ID of 0. Oh, token ID of 0 right here. See? A minted token ID of 0 for us. And to check if you're actually the owner of the NFT, all you gotta do is just do balance owner of token ID right here. If I put in 0, call, boom, there's the address. There's the wallet address that I talked about, which is the wallet address that's here. See the C4 wallet address? Exactly. So that means now the public mint opens and it requires payment. So that's awesome. So we've got our add payment. The next thing I want to add is limiting of supply. Limiting of supply. Really, really useful. And limiting of supply is very useful because when you go to an NFT project, and let's just say you have 10,000 items right here, that's your maximum items. 10,000 items, 6.5K owners, of course. It's how do you limit this 10,000 items? Because technically right now, we can mint 1 million, like from our contract right now. We can mint 1 million, 2 million, whatever you want. Doesn't really matter. The token ID will continue to increase nonstop. So how do we decrease that? Well, very, very simple. All we got to do is we check the supply of the actual NFT. This is why we actually did this ERC 721 enumerable. There's a function in that specific contract that basically allows us to do this. So check this out. I'm gonna go back to our public. I'm gonna say require. I'm gonna say total supply So should be less than, right? Should be less than some number. The total supply, I know it's a weird number, but total supply is how many NFTs were minted so far. That's how many NFTs were minted so far. So just remember, you understand that. It's not the max supply. It's how many NFTs have been minted so far. If it was 0, then it would be 0. If it's 1 person minted, it'd be 1 total supply. Got it? So that's going to give us that. And all we need to do now at this point is, and actually I could just show you an example here. If I go to here, show you the total supply right here. You see, we minted 1 NFT and now we got 1 NFT. Boom, right there. So total supply is going to be less than something. So let's go ahead and create a variable here. uint 256, uint 256. I'm going to give this a variable. It's going to be a variable max supply. And let's just say for now, we're going to create a max supply of, let's just say like 3, because I want us to actually test it out and see if it properly works. Or let's just say max supply of 1. So we only can mint 1 right now. That's it. That's your max supply. And then less than, we're going to say total supply is less than max supply. If we have went above that, meaning if someone else tries to mint, but we have reached that max supply, we're gonna say that no more supply, or we're gonna say we sold out. Basically, this means that's it. The NFT project has sold out, and you are all set. If I go ahead and just do that, and if I just save that, and we deploy our contract one more time, let's go ahead and try to deploy our contract one more time here, and let's actually test it out. So let's go ahead and remove this part. Boom. Of course, we always need to remove our previous smart contract and deploy our new smart contract, because change the code. It's not like VS Code you can just change and then it repairs newly. I will go ahead and do deploy. Make sure this is 0, by the way, when you deploy. Make sure that's 0. Boom, that's deployed. So now we have our contract at the bottom right here. I've got a public mint function, and I'm gonna put in my GUI. I had my GUI from the previous one. Boom, right here. And I'm going to hit public mint. Okay, that's gonna mint 1 NFT for me. And right, so that's all good. Now, technically, if I mint again, it should give me an error. So let's try that. If I hit mint again, because of course we have our max supply to be just only 1, right? And if we look at our total supply right now, it's only 1, right? So let's see here. Let me try to mint again. Let me put in my value one more time. The GUI. I'm going to hit public mint and check this out right here. Boom. It says we sold out. Is that right? So that's it. That's it. Now nobody can actually mint this NFT. And so, you know, that's it. Like that's it. Your mint is pretty much done. Your mint is pretty much done. So that's pretty cool. That's our max supply. So next thing we want to do, and that's going to be the more harder part, is going to be actually, we need to add a allow list mint, right? This is where we want to make sure that only certain people can mint. So we're gonna have 2 mints, right? Single here and doom. We're gonna have the public mint, and then we're gonna have the allow list mint. So the public mint is gonna be the public mint right here on the left section. Then we have the allow list mint, boom, on the right section, right? The public mint is open for everybody, as we know. And the public mint is gonna have a price of 0.01, while the allow list mint is gonna have a price of 0.001. So it's even smaller, 0.001, right? Ether, right? So it's even smaller. So allow list mint usually will allow people to mint at a much cheaper price, right? That's our allow list mint, right? And in terms of supply, I mean, honestly, that's pretty much it in terms of allow list mint, all right? And of course, we need to make sure that when you enable allow list mint, we disable allow list mint. So there's a few things we need to do, okay? The first thing we need to do is, let's go ahead and create an allow list mint functionality, right? So I'm going to go ahead and say create function, allow list mint, right? Boom. It's the same thing. It's going to be public, payable, of course, payable, boom. So you can see here. Awesome. 337. I like how it says infinite gas. It doesn't really kind of proper. That's pretty much it. Okay. Public payable. Beautiful. In this thing, of course, we are now inside here, right? We are going to still require payment, but this time the payment is going to be smaller. So 0.01, right? 0.01 ETH, right? In terms of max supply, we still want to make sure we limit to certain supply. Boom, right? In our max supply, we might have an allow list max supply. That also can count a lot, right? So we might only allow for the allow list, we might only allow, like, just say, I don't know, like 100 versus 1,000, right? So we can also do that. In our case, we'll just keep it a max supply for now. Okay. The main functionality is going to be pretty much the same here. Boom. right? Except one thing, right? Because if we do this, technically now everybody can just allow list mint. If I launch this right now, this is a public function that anybody can use right now. And just, hey, I'm like, why should I use the public mint function if I could just use the allow list mint function? You know what I mean? And so people in the Etherscan, you know, when they go to Etherscan and they will have the allow list mint function. That's pretty much it. Kind of like when you go to Bored Ape Yacht Club here. If you click on your NFT, let's just say here, and you go to details, right? And you simply just hit the contract address and you go to the contract itself. And if you go to the right contract, you will see there's a mint ape function, right? Well, people can technically use this function to actually mint an ape. I mean, before, not anymore. But you will also have an allow list mint function inside here, and people will just use that one if you don't and they disable or enable it properly, right? So what we need to do now is a few things. We need to set variables to allow public mint to say, hey, we have public mint open and then private mint, allow list mint open. We'll say add public mint and allow list mint, like so. Allow list mint open variables, boom. Okay, so let's do that right now. So we have our mic supply. What I want to do now at this point is create a boolean that's going to say, hey, what is open when? So I'm going to say here bool, okay, say public, and you remember in Solidity you have to specify, you know, if it's public or private, whatever it might be, public, and we're going to specify here public mint open, and for now it's just be equal to false, right? So meaning nothing is open right now, right? We can't public mint, right? Same thing goes for the allow list mint. Bool public allow list mint open is equal to also false, right? So technically we will not be able to mint either the public mint or the allow list mint. So to use these, well, what do you think we need to do? How do we use this allow list mint open inside our allow list mint function? Well, it's very simple. We need to require at the top here, require allow list, just copy and paste this, allow list mint open here. This needs to be true. If it's not true, then you can say allow list mint closed, right? So basically this needs to be true. If it's not true, it will just say allow list mint closed, right? Same thing is going to go for the public mint, guys, by the way, right? Same thing goes with the public mint. So we're going to say here for the public mint, we're going to say require public mint open. There we go. Yeah, right. Yeah. I think did I copy that right? Public mint open. Beautiful. So we say here public mint open, like so, right? Public mint open. Awesome. Public mint open. Just making sure I spelled that right. And then if it's not open, then we say public mint close, right? So that'll be the error you get if you try to mint, you know, with a public mint function, right? And technically that's what you will get. So let's go and test this out. So we've got these requirements for both functions, and let's now test these out. Okay, let's go to back to our deployment right here on the left side, as you guys can see. Let me go and remove this section. Boom, boom. Removed our previous contract so that we don't have to bother with it, and then just hit deploy, right? Deploy, here's our contract now. Beautiful. Now, the cool thing now, what we're going to do is, let's just say public mint. We don't even need the price, because check this out. If I do public mint, it says public mint closed. You see? If I do allow list mint, it says allow list mint closed. There we go. So that way nobody now can mint, no matter how much money you have, right? So that's how these projects limit which point you can mint and which point you cannot. Moving forward, we need to create the ability to edit these public mint windows, right? So we need to be able to give the ability for a owner or the creator of the smart contract, like you should be able to edit it, because otherwise you're screwed if you cannot edit your public mint windows, right? So what we need to do is create a function called edit mint windows. Simple as that, right? And in this function, we'll have a few things that we'll take in, right? It was a parameter. We created a boolean that's going to be underscore public mint open. I use underscore because it's different from the actual one. Oh, people, I said it's wrong. It should be public, not public. That sounds funny. Let me make sure actually it's here too. Yeah, it's public. There you go. Yeah, I could just caught that. Yeah, so I had I instead of you here. That's okay, right? So we have the public mint open, right? And I use this underscore. It's that way it still tells me what variable it's gonna be. It's gonna be changing, but the underscore allows us to create errors, right? I'm gonna say underscore, and it's gonna be the allow list mint open, like here, right? And this is something we would pass into our function. You know, when I change the public mint and the allow list mint open, right? So this would be an external. Now, what external means, just for those who don't know, means this cannot be used internally. It's actually just mainly used for calling functions outside of the contract. So I cannot use this function inside the contract itself. External, and then I'm gonna say only owner, because of course, you cannot just have random people saying, oh, now the public mint is open. Oh, now the allow list mint is open. That's not good, of course. So we need to change it to this to be only owner and save that. So at this point, this is going to be passed in by you, the owner. And then what you can do is you can say, you can now change these variables, right? So I'm going to say here the public mint open here. Let me go and say public mint open is equal to this underscore public mint open, right? So it goes with the allow list mint open is equal to underscore allow list mint open. Boom. So this will now allow us to modify the mint windows. Boom. Modify the mint windows, guys. Got it? Awesome. So we've got that part. Now let's actually test this part out. Again, let's go on back to our contract right here. Let's go and remove this and deploy this again. All right. So now if we've tried to public mint, of course, we're going to get this here. Public mint closed, allow list mint closed. All right. Oh, of course. Now, if I try to do the edit mint windows section, I'm going to say now the public mint is open. I'm going to say this to be true while the allow list is still closed, right? False. Let's go and transact, right? So we've changed those values now, right? And now, because we said the public mint is open, we can now mint. And to mint, of course, I need to pass in my GUI value. Do that right there. There we go. If I go ahead and hit public mint now, boom, see, now it went through because it was true. The second I try to do it false, if I change it to false again, if I try to public mint, of course, it will be public mint closed. You can see, so now I can change public mint versus allow list mint. Let's go. I want for you to test the allow list mint, but we cannot test the allow list mint because we have a max supply of 1. So we need to change the max supply to be like, let's just say in our case, let's just give it 1,000 because we know that works. So let's just say we have 2,000 NFTs. Boom, save that. Oh, beautiful. All right, let's go ahead and remove this part. Let's go ahead and deploy again because I want to show you something. All right, it's going to change the mint windows to be, this is going to be false while the allow list mint is going to be true. Hit transact. And now let's try to actually do the allow list mint. Now, the allow list mint requires 0.001 ETH. So if I go ahead and convert that, in my converter 0.0 ETH, I'm going to copy this amount of GUI, go back to my Redux, boom, put it back into my value here, boom, and then I'm going to hit allow. Beautiful. So we just minted our NFT, right? As you guys can see here in the bottom, and it's going to be a token ID of 0, right? Now, with the allow list mint, right? Remember, it's for only, they call the VIP people, or it's for people who are hardcore, you know, they're the hardcore people of the project, right? It's people who really care about the project. They put their sweat, tears, you know, eyes, you know, their blood, everything into the project. They were mods, you know, and so of course, only they should be able to mint. Now, how do we make sure that only certain people can mint this NFT? We need to create something that will allow us to require only certain people. So here, create, not in the public mint function, but in the allow list mint function. I'm going to say here, boom, require only the allow list people to mint, right? So only certain people can actually mint this NFT. Now you're like, oh, well, how do we do that? Well, what we're going to do is we're going to create this array. So imagine, it's almost like imagine like this. You have this array of people, right? You have these wallet addresses. I'm going to make sure, let me go ahead and do text. So we're going to create this mapping that's going to have these wallet addresses, and it's a mapping that's going to look like 0x blah, blah, blah. That's going to be your wallet address. That's going to map directly to true, right? So it means you are allowed to mint. Same thing then goes to another person might have, for example, 0x blah blah blah. That might also be true, right? So these are the people on the allow list who can actually mint, right? And we can check that. To create that mapping, we will create the allow list mapping. So let's go ahead and do this. Say here mapping. Right, and it's going to be address, going to be direct to bool. So the address of the allow list person, and it's like meaning, hey, they can actually mint the NFT. And then boom, boom. And then I'm going to call this, this is going to be a public, sure. I'm going to call this the allow, right? That's the actual list of people who will be allowed to mint your NFT. Right, that's the allow list. So mapping, right? Beautiful, right? Okay, let's go and save that. Now, the question becomes, how do we now change what's in this mapping, right? How do we change what's in this map? And we need to create a function that will actually populate this. This is a function that can be populated sometimes either in a constructor, and sometimes that could actually be populated directly in a function. So let's go ahead and create a set. Let me go ahead and do this here. A set allow list. I'm going to create here a functionality above, underneath everything here, underneath this public mint function, set allow list. Okay, set allow list, right? And this is going to be an external function. So there's no need for us to call internally. It's going to be an only owner function. So only the owner can do this, right? Because if anybody can add to allow list, then what's the point, right? Only the owner function, only owner can actually do this, right? Now, what are we going to pass into this? That's going to be an array of data. So it's going to be an array of addresses, right? So I need to create this array of address. I'm going to say here address array, right? Call data addresses right there. That's the array of addresses that we are going to be passing into the function to actually populate our allow list, right? Now, to populate the allow list, unfortunately, there's multiple ways you can create the allow list. There's a Merkle root, stuff like that. Right now, we're just going to create a for loop that will go through the array and actually populate the mapping. So I'm going to say here for loop for uint 256 I is equal to 0. Of course, I should be less than addresses, these ones here, right? Dot link, boom, right? It's kind of like your normal, what's it called? Your normal for loop in a normal, JavaScript. Oh, I forgot to put uint right here, right? So, and then I'm going to say allow list here, addresses, a position I, which is 0, 1, 2, 3, so 4, right? Is going to be equal to true. There we go. So basically what we've done here is we have appended whatever we have in this array into the allow list mapping that we have here on the top, right? On the top right here. And so that's what we just did, right? Now, of course, what's the point of populating this if we can't use it? Well, no. Let's use it actually. Okay, but I'm gonna go ahead and write this down inside here. This is gonna be populate the allow list. Wow. Okay, and I'm going to save that. Okay, very, very, very important. Okay, cool. Now let's go ahead and inside the allow list, by the way, we need to check, is the person on the allow list, right? It's like, when you go to a bar, when you go to like a bar and, or like an event and they check, okay, are you on the list? Are you on the list? What is that list called? Are you in a VIP list? Whatever it's called, right? And they check your name, for example. If you're not, you go home, right? So in our case, of course, we need to check that in the allow list mint functionality, right? So to do, all we got to do here is, of course, we check the allow list mint open. We say require. Okay, boom, right? I'm going to say here require, and then I'm going to say allow list message.sender. So this will allow us to look if the message.sender is in there, right? Is in the allow list that we populated before. Message.sender. Again, the message.sender, that's your MetaMask wallet account, right? And then if you're in there, then great. So this returns true or false, depending if you're in there or not, okay? If you're true, then great. But if you're false, sorry, you are not on the allow. And because of that, you will not be able to mint, pretty much. Does that make sense? All right, so this is how we're going to check. Hey, are you on the allow list or are you not on the allow list? Which is, of course, right here, right? Where is it? Yeah, which is, of course, right? Our mapping right there. Beautiful. So now this will actually check if you're in the allow list or if you're not in the allow. All right. Now, all we got to do at this point is just simply test this. Let's go ahead and test this out now. Right, let's go ahead and hit deploy. Beautiful. Hit deploy. Okay. All right, here's our contract right there in the bottom. Right. Of course, we cannot either do public mint or wireless mint because we need to edit the mint windows. So we need to have public mint is going to be open. It's going to be false. Allow list mint open is going to be true. Exact. Right. So so now it's both. Now we gotta double check the allow list. So for the allow list, we need to paste in the GUI amount. This always happens. So trying to paste it in is always so hard. It doesn't allow me. Right. If I try to mint it now, check this out. It still tells me, no, you are not in the allow list. So I cannot actually mint this functionality right here. Boom. See, it says you're not on the allow list. It's like, go home, Okay. To actually add us to the allow list, that is where we need to populate that mapping. I'm going to copy my address, the C4 address. Copy this one. Just hit copy on this section right here. Hit copy. Actually, this should be called set allow list. It should be somewhere inside here. Set. There we go. Okay, that's fine. So there you go. Boom. All right, put it into quotes. Now you paste in the address. Okay, and hit transact, right? And hit transact. There we go. Okay, so this put us in the allow list here. This put us in the allow list, and so we're now part of the ad. Now, if we double check this, now if I go ahead and place in the value again here, the GUI amount, and if I try to mint my NFT, check this out, guys. I want you to watch this. Allow list, boom, it just went through because I am on the allow list. I passed the correct value for the amount. And of course, you can see the value decreases. And then you see that the balance of the contract is now 0.001 ETH, right? That's right, because just so you know, whenever you do mint an NFT, your money does not go to you, to the owner. It goes to the contract, right here. That's the interesting part. That's right. Right. So the balance of this is now 0.001 ETH. I can do it again. You'll see now here. I can now do it again. Boom. Hit transact. Boom. There it is. Right. I just transact another one. Now the balance is 0.02. I can also change it to where both allow list and public mints are open. So if I just set these both to true, then you can set both. Boom. Transact. Right. So right there. Right. And so if I just go ahead to public mint, of course, I have to pass in the value with the 0.1 ether. So 0.00 way as much. Right? If I go ahead and put that in again, fix that up, boom, try to hit a public mint. All right, boom, we got it. So now we've got a few NFTs. If you go to total supply, you will see that we minted 2 or 3 NFTs at this point, right? So beautiful. So we got the allow list mint, we got the public mint, that's all working. You know, it's checks to make sure you're actually on the allow list mint and so forth. Now, the one thing I want us to do is to clean up this code a little bit to make sense a little more. Because if you look at this allow list mint, you can see that we have a lot of very similar stuff. We sold out, exactly the same function. Not enough funds, like exactly the same function. Well, I mean, that could definitely change per allow list mint. You know, this token ID stuff, all this stuff is pretty much the same. Like this stuff, you know, it's pretty much the same. So what we're going to do is we're going to create a separate function called a just a mint function that's going to do the repetitive stuff. So check this out. It's something I do for my clients actually. When we go ahead and do these, you know, big projects, we're always about, okay, how do we simplify the code? How do we make it more gas friendly? That kind of stuff. So if I go to my function here and I go to, you know, the mint, I'm going to call this mint, literally internal mint, right? So this is going to be only internal. Okay. It's going to be only internal. Okay. And this is going to do the necessary stuff. So this is going to do everything that's repetitive, that's just it's going to do. So like this stuff, checking the total supply right here, boom, right? And now check this out. I don't have to do anything of sorts of like this. So all this stuff, because we put it in the internal mint, we don't have to do any of this now at this point. So the public mint, all I just say is I say internal mint. Internal mint, I call this function, boom, it's gonna call this function, right? Because remember, this is repetitive work. Same thing goes for here, not necessary. Just do internal mint, boom. Right? So now this allow list mint is going to call the internal mint. The public mint is going to go to the internal mint. And then this is stuff that's not necessary for this is what they share in common, right? So this is why we put it into a separate function because we don't need the extra code. Extra code means more gas fees, everything. And so it's very important. Okay. We can just double check it to make sure it all works. Let me go ahead and check this out. Boom, boom, boom. Let's double check this. Okay. Let's go remove this contract. Okay. Let's go and hit deploy, of course. Okay, let's change the mint window. So let's do what public mint. Yeah, let's make both true. It doesn't really matter, honestly. Boom, let's hit transact. Right, so now both are true. Both are open right now. Of course, usually you would have one of each open. You know, either public mint or allow list mint. And then at that point, we will go ahead and hit actually mint NFT. So I need to copy my Ethereum converter. So 0.01 ETH. That's gonna be for public mint. I'm gonna copy this GUI and go to public mint. Paste in, I know it's literally how you have to paste in the data. Paste that in and then hit the public mint segment. All right, so now we were able to mint the NFT, right? That one at least. And same thing goes to the allow list. You can see now the balance increased to 0.01 ETH. That's how much the contract made money. Very important, guys, right? I just want you to understand it's very important. Whenever and someone buys an NFT, right? When you mint an NFT, right? Like let's say the Bored Ape Yacht Club, when you mint an NFT, actually the money goes directly to, what do you think? Right here, the contract. And then you have to withdraw it. And so we can actually create a withdrawal function too. So you guys know how to create a withdrawal function as well. So you have to withdraw that money from the contract to whoever it is you want to withdraw to, right? Maybe that's yourself, the creator, the owner, whatever it might be. Okay, awesome. So moving forward, we've got that working. I'm going to create a withdrawal function now for you guys. Because as we get money into this minting, we need to withdraw the money somehow, right? So I'm going to create here withdrawal function. So here called function withdraw, right? Withdraw to what address? I'm gonna say here address _ editor. That's the address we're gonna withdraw to. It's gonna be an external function. It's gonna be used externally by only the owner, of course. Only the owner can do this, guys. It's very important. Only the owner can do this. Very, very important. Boom, like so. And then what we're gonna do at this point is the first thing I'm gonna do is get the balance. So get the balance of the contract. Boom, right? So it's gonna get the balance of the contract. So I'm gonna say here uint 256. Boom, balance. Okay. Is equal to the address of this meaning this contract specifically, this contract right now, the balance. We're going to get the balance of this address, right? That's how you just get the balance, right? So this will give us the balance. Now, with that said, I want to make this a payable. I'm going to create a payable address to this one. Address. There we go. Address dot transfer. Not like this one. No, it's not what I want. The transfer. This will transfer the money, right? That transfer the money. This amount of money. It's right there. Oh, spelled this wrong. There we go. So withdrawal function would transfer this balance from the contract to the address you specified. Okay. And that's how you would withdraw money now. That's pretty cool, right? I want to show you an example of how it actually works. Check this out. If I go ahead, let me go ahead and do this right now. If I go ahead and I remove this and I deploy the contract one more time, okay, boom, boom. Let me go ahead and edit these main windows to be, this will be true. It's also going to be true. Hit transact. Okay, awesome. We've transacted now. Let's go ahead and do the public mint. So we pass in the public mint amount, the GUI. Where's that GUI? Right there. Awesome. And then let's do public mint. Okay, we minted. Now you can see now is the balance of the contract is 0.01 ETH. So all we need to do is now withdraw that money into, well, I'm going to withdraw it back into this address, the C4 address. So if I just hit withdraw, I'm going to pass in the ad. Now, of course, only the owner of the contract can actually create this. No random person can just simply withdraw the money from the contract. No, that's completely bad, right? So we'll go ahead and paste in the address that we need to withdraw to. Here, I hit transact. Boom. You can see it transfers. Where was it? Let me see if I can find it here. Well, it transfers the money directly into here, actually. Into here. And now you can see the balance becomes 0. This actually is more visual when you use MetaMask, for example, to do this, to do this. At this point, we're pretty much done. Let's just go ahead and launch this on the test network, okay? So we've got our mint functionality. It's all working. All right, beautiful. Let's launch this on the test network in our case. To launch this on the test network, not on, because this is private blockchain right here, we need to change this from here to be MetaMask. So of course, this requires MetaMask, guys. You need to make sure you have MetaMask account, and then we're gonna do this directly on Goerli. How's it going? Nas from the future. As you probably know, some things have already changed with Goerli. So I want to show you the updated version on how to deploy your ERC 721 smart contract. Let's do it. So we've got our ERC 721 smart contract that you have built out at this point with the withdrawal function, the internal mint function, the public mint function. And what we want to do now is deploy it, okay? Make sure you have your MetaMask ready, and make sure you have Goerli ETH as well. Make sure you have some testnet. If you don't have that, you just have to go to the Goerli faucet, and just get some Goerli for yourself as well. For example, this is a good faucet from Alchemy, I believe. All you have to do is just simply sign up for Alchemy, and then you'll be able to receive some Goerli. Now, before we deploy the contract, I want you guys to update the IPFS URL because I have updated that as well. The IPFS URL should be down below in the description. So just go ahead and remove this whole portion like this, and then paste it in. Let's see. So this is my CID link. I'm just going to make sure I have it formatted correctly. Basically, you have the IPFS shortener. Then this is your CID, your unique identifier for where your images, your metadata is stored. And of course, we'll talk about that later. And then / because that's how we'll begin the 0, the 1, the 2, the JSON, and so forth, okay? Okay, let's go and save that, Command S. And let's go and now deploy, you guys. Go to deployment section at this link right here. This button right here. Make sure you have selected Injected Provider MetaMask. So in this environment, select Injected Provider MetaMask. And that might pop up your MetaMask like so, inside here, for example. You want to make sure you're also on Goerli Test Network. So if you click on this drop-down arrow, make sure you're on the Goerli Test Network. If you don't see that, you have to go into settings and change it. What we want to do now is hit deploy right here. Of course, make sure this is 0. Make sure this is all good. Injected provider should say Goerli. And let's just go ahead and hit deploy. All right, we pop up the MetaMask. Hit confirm. Beautiful. View on Etherscan to view our beautiful transaction on the Goerli blockchain. Okay, 0 ETH. It's going to take some time because that's what Goerli is. Successful. Yes, there we go. And on the bottom, if you see deploy contracts, we have our deploy contract. So you want to click on this little icon and scroll down. Let's go ahead and edit the mint window so we can actually mint the NFT. Click on this little arrow icon. A lot of people miss this portion. Click on this icon so you can see the actual parameters. And again, these parameters are the ones that are directly mapped to your function. Public mint open mapped directly to this one. Allow list mint open directly mapped to this one. And let's go ahead, set true to both of these. True. Make sure you spell them correctly, because of course I cannot spell. True. There we go. And just hit transact. Boom. Transact. MetaMask pop up. Hit confirm. And let's make sure that it transacts and set this all to true. Come on, 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 come on. Yeah, there we go. Okay. So it looks like that went through. We went out and we added them in Windows. Now we can go ahead and mint the NFT. I'm excited. Go ahead and hit the public mint button. Now, of course, if you hit the public mint button right now, it's gonna give you an error because, you know, say, hey, there's an error, of course, because we need to send it money. And how much is the public mint cost? Well, if we look at the actual function here, 0.01 ETH. To set that, you have to go back to this value inside your remix, and you cannot just do like 0.01 ETH, as you already know this. You have to use a whole number. So we are going to use our handy dandy Ethereum unit converter to convert 0.01 to whatever GUI is. Copy that GUI number, go back to our remix, and paste that in. Paste that in, and you should have the exact number for 0.01 Ether. When you have this, and very important, scroll down, and now you can hit public mint. Let's go ahead and hit public mint. Ooh, still says transaction executed has 40. You have not enough gas fees. Okay, let's make sure we have that. Oh, right, because this should be not Ether. This should be GUI, you guys. So now we can scroll down. Public mint, beautiful. We should pop up with 0.01 Goerli ETH. Exactly. And now go to the bottom and hit confirm. There we go. We are now minting your NFT. Hit on view on Etherscan. There we go. We've minted our NFT. Let's see how this looks like on OpenSea. Copy your contract address. This is the contract address you should see in Etherscan. Just copy that. Go to OpenSea or go to Google and type in OpenSea testnet. And just click on the testnet. Now paste in your address. Paste in your contract address. You should see the contract address, and maybe it says account, so maybe click on that. Sometimes it shows up, sometimes it doesn't. Sometimes you have to do it a few times. Sometimes you have to wait some time. Let's try it again. Let's hit enter on this one. Oh, there we go. As you can see, it did show up right here. And there is our NFT, you guys. This is our cute Web3 builder. And if you're wondering, how do we get these cute Web3 builder images? There we go. And how do we create the JSON metadata and so forth? That's going to be later on in this tutorial. But I'm pretty excited. This is really cool. Of course, we got the language JavaScript. The OS is a Mac OS, and the speed is mild. So there you go. This is your OpenSea now collection. And what's really cool about this is because you are the owner of this contract, you can now go ahead and even edit this collection. You want to make sure you log in. So let's just say, let's go ahead and let me log out. You want to use the same account that you created your contract with. See, this is my account right here. You want to go ahead and log in. MetaMask. Okay, there we go. I've logged in. Okay, let me go back now to my my Web3 builders. Now hit this 3 dots. Hit 3 dots. Hit edit collection. You should see that. If you don't see that, you probably did something wrong. So check back somewhere and make sure you repeat the steps correctly. Edit collection. There you go. Signature request. That's fine. Hit sign. Now check this out. Now you can change the description and the name of your whole collection. You can change your URL. So Web3 Builders Official, let's just say. Could be. Your category, which could be like membership maybe. Blockchain, run Goerli. ETH is the payment token. How do I want it to look like? We're going to make it look like covered fully. For graphics, we can even change like the logo image. Let's just say we can change pretty much anything. I have my logo image that I can change, for example. Check it out. There we go. Hit open. There's my logo image. Hit save. Hit OK. And now your collection is going to look amazing. Look at this. Web3 builders, you got your name, you got your description, you got your first NFT, and you're all set, my friends. Hope you enjoyed that video. If you got any questions, leave them down in the comments below. Other than that, don't forget to hit that big like button. Let's move on to the next one. Let's get into how do we create these epic NFT images using AI. So one of the biggest ways that you're going to be using to generate NFT images is using something called Midjourney. Midjourney. If you have not heard of it, you can go and check it out. What we want to do is just to give you some base knowledge on how to get there. Of course, all you got to do is just type in Midjourney into Google here. There you go. And you will be prompted with something like this. And this is your AI NFT or image generator. And it's probably one of the best ones out there so far. Let's check it out. So if you click on this, I know you can see it takes me to my account. I could just sign out. And you will probably be prompted with something like this. Now for you, what you want to do is you want to simply sign in. So sign in will actually connect you to your Discord. That's how you sign up to use Midjourney. For me, I will simply go ahead and sign in. And I will hit authorize. That connects me to my Discord. And there we go. There is my NAS and so forth. And that's pretty much it. What we want to do now at this point is a few things. When you sign up for beta, let me go ahead and show you what happens when you click on sign up for beta. Let me go ahead and sign out. When you hit the join beta, it should later on take you, for example, to Discord, as you can see right here. It should take you to Discord, at which point you will be signed up. How do you now use Midjourney? The way you use it, it's actually not that difficult. Go to any of these, you see these rooms, newbies here, 154. Just go to any of these rooms, doesn't matter. And again, might be already different, the time you're watching this, but this is where people are generating, in these channels, they are generating these images. For example, you can see an image here that's really cool, like this is a logo. This could be like a squared round edges mobile app logo design. So what we're going to do is we're gonna generate our first image. So I actually like, for example, I have these characters that I've made previously. So if I sign in to Midjourney here, if I sign in, authorize. So I love these characters, for example, because they're like coders to me. They're like blockchain developers, coders, and so I thought they were pretty cute. And this is what I use. I use 2D illustration, super deformance, chibi, stock character design, cool coder, computer, coffee, 8K. I don't need the 8K. So I'm gonna copy this one. So the way you create an image is you go to one of those channels and then you say / imagine, and this is what you want to imagine, right? So what do you want the image to be? In my case, it's gonna be a 2D illustration. Actually, let's try a 3D illustration, chibi character, illustration. Make sure you spell illustration correctly because I believe I misspelled it. Coder, drinking coffee, and coding. And we'll just start with that. Let's see what it does for us. You can see it says wait to start. So you do kind of like have to almost like wait your turn here because there's just so many different characters that are being made right now and so many images that are being prompted. It's pretty insane. Okay, scroll all the way down now. Now, since it has generated the image, if you scroll all the way down, that's where you will find your image. So there you go. You can see there's your chibi character, coding, drinking coffee, looking pretty epic. I feel like these would be pretty epic NFT images, honestly. One thing you need to realize is at this point, what now, right? Okay, you've got your character, let's just say, and you now want to, actually potentially use them. So your options here. You can see there's U1, U2, U3, U4, and then V1, V2, V3, V4. U means upscale. So it means make the image bigger versus V means variations, create variations of this image. And the way it happens is this is U1, this is U2, this is 3, and this is 4 right here. All you have to do is, let's just say you really love this image and you're like, okay, or let's just say, which one do I like? I really like this one right here. This is U4, okay? I'm gonna say upscale U4, so I'm gonna make this one bigger. And I'm also gonna make different variations of maybe like this one. This is a pretty cool one. This is a V3. So I'm gonna make different variations of this one just so I can see like, okay, what is it? Let's see, submit. So you can see here, this is creating different variations of that specific image that we wanted. And now it could be just different types of the same image that you might want to select from. So let's have it create those different variations. You can see it jumped all the way to the bottom. So I'm going to scroll all the way to the bottom. There we go. And there's my images. You can see these guys have got different hair. This is pretty cool. Actually, kind of looks like a little bit robotic. I really like the coffee straw here. Oh, this looks like a hot cocoa. That looks delicious. But there we go. What about the upscaled version that we asked ChatGPT to do for us? Well, we kind of have to find it now. There we go. There it is. This is now the upscale version of that image that we wanted. Remember? This is like a chibi. Looks like trying to drink some coffee. All you gotta do now is you can literally just copy this image, save this image, and use this image for your own NFT. Wow, it even created the Apple logo. That is pretty cool. What I like to do is I like to open it in the web actually, because check this out. If I hit open in web, and you might have to have it signed in, now you can see other different versions or related characters. And you're like, oh, this is cool. So you're like, okay, this is pretty awesome. Maybe I could create something similar. So you're like, okay, Now you can see a cartoon computer nerd boy with a hoodie. Pretty cool, right? You can now start to understand what prompts maybe you want to use in your image generation. There's some really cool, like even this cool design, for example, informatic engineer, chibi character boy, brown hair with glasses, GB style, right? GB style, colorful in front of a computer. And you can literally just copy these prompts. So, right, copy full command, and then you'll be able to get that coder. And this is how basically we'll be able to do it. So pretty cool way. So let's say try one of these. I'm gonna try, let's see here. I love it. Oh, this is even cuter. Cute mascot of a coder brand. Oh, this person, oh, this a gamer. Let's go. On a computer, full body, 3D animated cartoon. Love it. Okay, let's try this one. Let's try this one here. So we're gonna try this one. Let's go back to our Discord, right? Let's go back to our Discord here. And let's just type this in again. Again, let's do /imagine gamer on a computer. But let's make saying gamer, we say coder. On a computer, full body, 3D animated cartoon. Now, we're going to modify some of these features, okay? Because I want you to pay attention to this. So Midjourney actually has some really cool prompts that in terms of how to create prompts. And if we zoom in on here, you'll see. So first things first, you can actually give it examples of certain images. So you can say, hey, create me examples of these images. And this could be images to different links. So let's just say maybe you want to give it, hey, this is an example of the image or what I'm trying to get to. It could be even a drawing that you made, which is really cool, by the way. And then here's a description of what you're trying to create now. Description of what the image is, and there's parameters. So right now, we are simply just giving it a description. We're not giving it any example images, but you can do that as well. Then we got our description. But what about these parameters? So this is really cool as well. Let's explore some of these parameters. So you can see here, we have parameters and read more about parameters. So let's go and click on that one. And there's a lot of things you can actually say. So let's just say you want to change your aspect ratio to be not 1:1, by 2:3. You can actually do that too. So let's just say your aspect ratio is 16:9, which is, you know, a wide aspect ratio. You can actually do that. -- by saying -- aspect 16:9. So let's try that right now because, you know, maybe you want to use it for a video potentially. And then we say -- aspect 16:9. Then we have another one, which is really cool. It's called chaos. So chaos is basically how different do you want the images to be in terms of like variation. So you can see here, these images are kind of similar, you know, rounded. And this is something called a low chaos. However, if you want very different images to be produced, then you have to increase that chaos. So for example, here, you see here, the higher the chaos here, you can see now this is like rounded. Now this, you know, sitting on something, right? Very different styles. Same thing here. You see very different styles. So by higher the chaos, the more different images we get. So we're going to actually try do like --c, just say a higher chaos called 50, --c 50. Then I'm going to try another one. Let's see here. And this is called the stylized one. And the stylized, I like to think of it more as, you know, like quality, which is like how detailed do you want it to be. That's kind of how I think about stylized personally. And so the higher the stylized, you can see the higher the quality. This is the low stylized. So you can see kind of like lower quality, lower details versus stylized 750. Wow, very high quality. So we're going to do -- stylized 750. Let's see. Let's see what we get. Just hit enter. Again, we specified the aspect ratio. Look at that. Let's see. So it's a cartoon character, an anime cartoon character, as you can see right here. There we go. So there is your coder, basically. This is a pretty funny one. And you can play around with these numbers to see, wait, what do I like? Maybe I want the stylus to be small. So maybe if we just remove the stylized, let's try this one. Imagine. Let's try removing any of the stylized options and just let it flow basically by itself. This is pretty cool too. These ones are pretty cool. There we go. There it is. They look okay. You know, not the greatest thing, I would say, honestly. But this is how you can basically start to play around with this. And you really just have to try out different things. And I really like this because this could give you a lot of imagination, a lot of creativity into what NFT do you want. You know, what NFT do you want to create? And then maybe it could be the NFT that you actually want, right? I've made some cool chibis that like I love personally. And again, the way you want to get to that, let's just say you want to explore more. This is a really cool option as well. If you don't just sign in, again, if you don't just sign in and hit authorize, this is where it takes you to all the things that you have done previously. If you hit explore, and this is where you really explore what prompts you might want to use. So here, for example, let's just say I want to say character, or let's just say anime character. So this is some examples of an anime character. Expand the search here. These are the prompts, and you will be able to see what prompts people use. You see here anime, For example, here, anime. This person literally just used anime style poster, for example, right? And this is how you explore. Okay, what prompts do I need to use for what I want to achieve, basically. And this is how now you create NFT characters. And then when you get something, all you gotta do is just upscale it, save it as an image, and boom, you're done. You got yourself some cool NFT images. And that's it. Hope you enjoyed this video. Hope you get to create some really cool characters and images. And if you do create one, let me know down in the comments below. Other than that, I hope you have a great day. Don't forget to like, subscribe, and I'll see you later. Bye. You've built all these smart contracts. Now it's time to create your own NFTs and upload your own metadata. In this video, I'm going to show you how to create your own NFT metadata, how to create a structure in a way that's easy for you to upload it. Together, we're going to upload to something called IPFS using Pinata. And finally, you're going to see how you can use it in your own smart contract. Let's do it. Now, if you're wondering what is IPFS, how does it work, and why is it so important for NFT images or even just a blockchain space, let me show you. If you think about a Google Drive folder, right? You think about there is your folder right here, and of course your file is stored in that folder. This is, let's just say, this is Google Drive. Now, with something like IPFS, it is a decentralized protocol, and what it does is it splits up your file into many different parts and then saves them in many different directions. So let me show you here. So what happens is that, let's say you have this file, and let's say this is an image, okay? This file can be split off into 4 main parts. This part right here can be saved in one location, and that has its own little CID link. This part will be saved in another location. This part will be saved in another location that has its own CID link. And then this part will be saved in another location that also has a CID link, like so. And then what happens is there is one main CID link, which is, think of it as like a unique identifier. It simply identifies your image. And this is your main CID link. And you try to call that, this knows that, okay, there's all these other files I need to get. So it will try to combine those different files from all the different directions. And then that combines into one main file. The cool part about this is that because it's a hash, right? It defines what your image is. If you try to upload the same file again, it will also have the same CID link and it will share it. And so basically you will not have duplicates, because why? Because they have the same metadata. Let's go and show you how do we create the metadata for the NFT images, and also how do we upload the metadata to something called IPFS, or decentralized storage. Let's do it. Beautiful. So here we got basically an NFT metadata template that I have created for you. The link should be down in the description below, basically. So just go and scroll down and you should see that NFT metadata template. And this is what you should see. It might be a little bit updated if you see it, but this is what you should see. You want to download it as a zip. If you know how to use git clone, you can also do git clone using this link. But if you don't, that's fine. Just do download as zip right here. Okay, I'm going to do that right now. Once it's done that, you want to go ahead and unzip it, you guys. As you can see here, if you're using Mac, just double click it and it will unzip the whole folder for you. Once you have that, you want to open this in VS Code. I have opened up my VS Code right here. Sometimes you might just need to just simply go file and new window. And I want to bring up my folder. And this is a really cool trick. I could just drag the folder into VS Code. And there's your folder. So we got images, we got JSON, that get ignored, don't worry about that one. Images, this is where your images will be. So in my case, I have 0.png, 1.png, 2.png, 3.png, and these are some funny images that I generated using AI. And then you've got your JSON. So far, we're only going to create 4 different metadata files, okay, for 4 different images. You've got 0, 1, 2, and 3. And this is your metadata now. The first things first is you want to be able to upload the images, okay? So we have our images 0.png, 1.png, 2.png, 3.png. We want to upload those first. Let's go ahead and do this. Right click somewhere on this space and reveal in Finder. There we go. And double click on it. And you will see this 2 folders. Keep this one in mind for now. Open up a Chrome tab and you want to open up a new tab and call it Pinata, and open up Pinata right there. And right here, Pinata.cloud. This is where we are going to be storing our NFT images in something called IPFS. Let's go ahead and hit login or start building. If you don't have an account, so just hit start building to go ahead and sign up for an account. So just type in your email, but I already have a login. So I will log in with my username and my password. At this point, you should see kind of a dashboard like this. You can see some of my stuff is blurred out simply because, I don't want you guys to see that, but you want to go ahead and hit add files. And this is really important. Add a folder, not a file. Hit add a folder and you want to select the folder. Okay, select the folder. Here's my metadata images. Select the images folder. Make sure don't select the images themselves, but just the folder itself. So select that one and hit upload. Hit upload. There we go. Name it. And let's just say we'll call it Web3 Builders Images. Just hit upload. And so here are my Web3 Builder images, okay? Here they are. This is my CID link. And what you want to do, check this out. If you click on the preview, you will see all your images. If you click on an individual image, it will actually take you to that image as well. This is the really cool part. So if you click on that image, there we go. Okay, it loaded up the image. There it is. It's a pretty big image, as you can see. So let's go back now to our files. What you want to do now is copy this CID. This is your unique identifier for your folder. Imagine like a sharing link for the folder itself. So let's go and copy the CID link. We want to keep that one in mind. Let's go back to our VS Code now. We're going to be working with JSON files at this point. First things first, you want to see, and 0, 1, 2, 3, these correlate directly to the IDs of the NFTs. 0, 1, 2, 3. This is going to be the name, description, the image, and the attributes of your NFT. So if you want to see how metadata works, all you got to do is go to OpenSea and just type in OpenSea metadata. There you will see the metadata standards for your NFTs. And you'll notice here, this is actually how all NFT images are shown in the space, in the NFT, in the marketplace space. They use this standard as a way to show the NFTs. So for example here, description directly correlates to description, for example, on here. The name directly correlates to the name that you have inside here. Then you've got your attribute, the image link. Then you've got your attributes. And these are your attributes. These ones are here, right here. So that's how the NFT space, guys, works. If you look at an example, like let's just say we go to OpenSea and we select any NFT project. Let's just select any, like Azuki, I love Azuki, and click on any NFT image. Just click on any NFT image you want and just scroll all the way to the bottom and you should see details right here. Hit details and click on the token ID right here. Click on this token ID. Click on it. You will see the JSON metadata. You will see the name, the image, and in this case, the attributes. Here, the name is Azuki7779. And if you look at the name, Azuki779, it directly correlates to an NFT. The image, same thing. This is 7779 image. Attributes, look at this. Type, human. Okay, let's go back. Let's look at our type. The type is human. This is how these marketplaces work. This is how they're able to work together, is because there's a standard for how we upload the NFTs to the images, okay? Or how do we upload NFTs to the IPFS? And you'll notice as well that it's also stated in IPFS. So just something to think about. Again, going back to our VS Code, we want to create a name. So in a name, I'm going to call it this, Web3 Builders. I'm going to call it 0. So that's going to be the 0th Web3 builder. Description, I'm not going to give it a description. Attributes, I'm going to give it, let's just say, language. So maybe my Web3 builders are different languages. So this could be, for example, like JavaScript. Some could be Python. Then it could be like OS. Again, these are my attributes. You can change yours. You can add more attributes if you want as well. And then the value could be like Mac. And then my third attribute could be something like speed, because we all love JavaScript. There we go. Now for the images, however, this is really important. Remember how we copied our CID link to the images folder. Again, I'm going to copy this again. I'm going to select here and I'm going to paste it in now. But before I paste it in, I'm going to say IPFS : // Basically, this tells the marketplace, hey, okay, we're using IPFS, so link it to IPFS. Then we're going to paste our CID and you want to do /0.png. That's whatever the name. And again, this is very important because this directly correlates. If I go ahead and show you here, this 0.png directly correlates to whatever you have inside your images folder. Think of this as a link to the folder that's in, Google Drive, or in this case, IPFS. And think of this as you're getting the 0.png from that folder. So if this is a JPEG, then this should be technically called what? JPEG. So there we go. So we created our image. We've created our name. Of course, you can also add description, and we've added our attributes. Now what you want to do is you want to do the same thing to all the other, the 1, the 2, and the 3. So just fill all of those out. I'm going to fill them out, and you will see them here in a second. Okay, so I went ahead and I filled out all of the other ones. Of course, you should have done this as well. And of course, make sure you have the right language types, the trade types, the values, all of that stuff. And make sure that this folder image is always the same as well. So this folder image right here, that has to be the same, which is really important, okay? But of course, you have to change 3.png, 2.png, 1.png, and 0.png, okay? Very important. Now it is time to upload the JSON. Let's go right-click somewhere outside here. Review in the Finder. Okay, so we can see the folder, and there is our JSON folder, 01 with 0123. So keep that there. Go back to Pinata. As you see, we've got our images. Now we're going to upload our JSON metadata. So hit add files, hit add folder. Again, folder is very important, and you want to select it. And now instead of uploading the images, we are going to upload the JSON. Let's hit the JSON folder, select that one, and hit upload. Hit upload and call it Web3, in your case, Web3 builders metadata. Hit upload. Beautiful. And there we go. There it is uploaded, and you should be all good now. At this point, what you want to do is you want to hit view. It's going to take some time for it to view the folder. So just hit this little eye icon. When you have the paid version, it is a lot faster, I will say.
2,000 years later.
There we go. If you now click on it, so if you click on 0, let's just say, let's click on 0, you should see your JSON. And how you test your image, how you test if all this should technically work, the best way is to also, of course, put this IPFS into the smart contract. But in your case, what I'm going to do is notice this IPFS link, and I'm going to copy everything besides the IPFS : // Gonna copy this part, and then in my URL, I will paste it in. I will remove everything that is IPFS / and paste that in just to test if my image works. And there you go. My image is working. And so this should technically work in the smart contract, and this should technically work in OpenSea. Of course, the best way to test this would be to test this and actually put into a smart contract. And if you're wondering, what do you use a smart contract? The link that you use is this link. This is the metadata link. That's the link that you're going to be using, right? It's going to be IPFS : / CID link / and that's where the smart contract is going to append 0, 1, 2, or 3. And that's it, my friends. In that case, hope you enjoyed this. I'll see you guys next one. Don't forget to like, subscribe, smash that like button, do all the things you got to do to it. Other than that, I love you guys. Have a good day. Bye. Let's build the ERC 1155 smart contract. This is a fun one. We're going to add the public mint functionality. We're going to create the allowlist mint functionality. In those functions, I want to add a supply limit. I want to add a payment requirement. I want to show you what is the difference between an ERC 1155 and an ERC 721 smart contract. Finally, I'm going to show you how to add a withdrawal function to take out the money from the smart contract. And we're going to add a payment splitter so that you can split your project revenue amongst project owners. Finally, we're going to test out the smart contract on the Goerli test network so you can view your NFTs on OpenSea. Let's do it. As you can see right here, we've got OpenSea open, OpenSea open. So let's start out with creating our first ERC 1155 smart contract. But before I do that, Nas, what is an ERC 1155 smart contract? How does it compare to ERC 721? I have no idea. So here's the difference, okay? If you're going to think about like ERC-721 smart contract. So this is the original smart contract that was created. CryptoPunks used it first, then we got the Bored Ape and stuff like that. So they were the original pioneers. This contract was the original pioneers. And with this smart contract is so cool because you can own unique NFTs, right, and so forth. It means is that only one owner per NFT. Where ERC 1155 changes is that at this point you can actually have multiple owners per NFT. Interesting, right? So now it's like, what the heck? What does that mean? Well, let's take a look at this. One really cool one that is an example is like this one here. We have the Adidas Originals into the metaverse right here. As you can see, there's only 2 NFTs, right? We've got the first edition, the second edition. And if you go to these NFTs, you will see that how many owners are there? Well, you will see that there's actually 4.4 thousand, right? So 4.4K owners right here. So that's what you'll be able to do on your side as well, is that this is very much used for utility purposes. Let's just say maybe you want to create an NFT project, to be able to give access to a certain portal, right? To be able to give access to, I don't know, maybe you have some subscription, and it's been pretty successful. And so you can do this also for your NFT project. Okay, let's get into the ERC 1155 functionality behind. Let's just start out with creating the ERC 1155 smart contract right away. What I want you guys to do right now is go to Open Zeppelin here, and go to Open Zeppelin. I call it the wizard, right? The Wizard of Oz. No, but the wizard is what's going to allow us to kind of set up the base smart contract, right? So here it is. We're on the Open Zeppelin wizard. We don't need the ERC 721, we don't need the ERC 20, but we do need the ERC 1155 right here. And let's go ahead and click on this one right here. And let's go and name our smart contract. Mine is going to be called Web3 Builders, Web3 Builders. And the IPFS, guys, IPFS is a link. I actually have the link in the description. So here, I will go and copy this. Boom, boom, boom. As you can see right here. Boom, right here, right? So this is where our images are stored. And I have a few images stored in this IPFS link. We can cover IPFS in another video. Now, moving forward here, we want to make this mintable. Burnable, not so much. Supply tracking, yes. We want to check the supply of this. And then, yeah, we can make it possible as well, right? And I think that's pretty much it. Now, let's go ahead and copy this specific Web3 Builders contract. You can either click this. Honestly, though, it never works for me. That part never works for me. For some reason, this copy to clipboard never works for me. So I like to do it this way. I like to copy this myself manually and then open up Remix. Boom. Remix IDE contract. Okay. Now, then let's go and create a new workspace. Let's go and name this workspace ERC 1155 smart contract. These are the three beginning smart contracts we have inside here. I can zoom in this for you guys a little bit here, as you guys can see. Right, so you guys can have some better context. We don't need most of this stuff, honestly. So what we need to do is create a new smart contract and call Web3 Builders. So let's go and create under contracts, hit new file, and call it ERC. I'm gonna call it Web3 Builders. ERC 1155.sol. Right, Solidity, correct, right? And of course, we got nothing now at this point. So let's go ahead and paste this in. Paste in our whole contract that we had and just save it. And then honestly, it should be done at this point. It should be done. Here's what it looks like, right? Here's what it looks like. Pretty simple, right? So this is the base contract. I would call it that way, right? The most basic contract out there. We've got the set URI function, which allow you to change the URI. We've got our URI right here. We are importing the ERC supply, which allows us to track the current supply of the NFT, which is how many NFTs have been minted so far. So it will allow us to track that part. Pausable means you can actually pause the minting if you wanted to, right? Ownable, you have to have this one, guys. Is really important. Ownable means it shows who's the owner of the contract. And sometimes if you don't have an ownable contract, you will have an issue later on down the road with OpenSea, for example, or with like Rarible. Trust me, I have learned the hard way, guys. Trust me. So you want to make sure you include this smart contract inside here. Let's go ahead now and go into the mint function. As I'm doing this, I'm going to hit some music that's going to be playing in the background while I'm working on this. Okay. The first things first we need to create with the mint function is remove some of this stuff and clean it up. Okay. As you can see, we have the account we're passing in to mint the actual NFT, right? Now, in terms of the account, we don't need it because there's one really cool thing we can do to specify who's minting the NFT and that's using something called message.sender. Message.sender, for those of you who don't know, what that does is that basically gives you all the data about which MetaMask account is actually making the transaction, right? So let's just say if you're minting, it's going to be your wallet address. If, you know, at the same time, we'll be able to see things like how much money are you passing into the contract? How much money are you giving to us, right? All of that stuff. So this happens in the message object, I call it, okay? So remove that, message.sender, beautiful. The ID is what ID NFT are we minting, okay? Then the amount, how many of those are we minting? And the bytes memory data, that's like external memory we don't need to add as well. So that's gonna be nothing. To fix this part, of course, let's go ahead and remove this data portion. The account, we can remove this account section. The other thing you want to look at this is the only owner part, which is what this is, right? Why is this bad? Because this means only the owner of the contract can mint this NFT. And that's no bueno. right? That's like, oh, great, I just launched a smart contract, but I'm the only person who can mint the NFT. Hence, really, it's like, it's just for me, pretty much, right? So we don't want that. But what we do is we can just simply remove this, and that's pretty much it. And now this, but you can mint the NFT. Oops, not here. Sorry, not the mint badge, but actually in the only owner part. There you go. See? So now anybody can mint this NFT, and that should be all fine. After we've done the minting part, let's take a look at, how do we make sure that, someone is sending payment. So the second thing we're going to work on is payments requirement, right? So this is, of course, you need to be able to require payment upon when somebody mints your NFT, right? So let's go ahead and do that. To require payment, you need to set the function payable. Very important here. So we have a payable. And what this does is this says, hey, this function right here is actually allowed to take payment. So basically, as we pass in money to this, so you have to call this function payable. Otherwise, you cannot really pass money into this, okay? Now, we've got the payable, but doesn't mean we're actually requiring payment. To require payment, what we need to do is say require. And those of you who don't know what require is, it's like, hey, make sure this condition is true. Otherwise, we stop everything. Otherwise, we stop everything underneath this. This is why it will never get to the main function if this condition is not true. Let's come require payment. To figure out how much money you're passing into us, again, we're using the message object. Inside the message object, we have something called a value. And value is how much basically money in way is given to us into the contract. Does that make sense? So let's go ahead and say message.value needs to be equal to what? Some kind of price. So let's go ahead and create a price above here. So what we can do here is inside here, okay? Do uint 256, that specifies basically 256. I'm gonna call this public price is equal to, let's actually make this a public price. Yeah, public, right, is equal to, what should we call this? Let's make this 0.01 ether. And very important here, you need to understand this is ether. You cannot say ETH, right? It doesn't exist. Ether, that's right. And at the end of the day, just so you know, this gets converted into something called Wei, which is kind of like a smaller version of ether. Think of it as like you've got, if you have inches, then you have what's more than inches. Actually, I don't know. It's like inches, feet, and then like meters. I guess you can say. I guess is the way we would say this, right? So in our case, this would be like inches versus. This would be like feet versus Wei would be inches, basically, right? Just same amount but different measurement of unit. Okay, so you got the public price. Beautiful. Awesome. Moving forward, let's go ahead and say message value should equal to the public what? Price. That's what it should equal to. Now, if that's not it though, if it does not equal to the public price, then what we do is we say, hey, wrong, not enough money sent. Not enough money sent. That's right. Not enough money sent, right? So basically, that's going to be making sure, again, that we require payment in the contract. So let's go ahead and test this out and see how that works out, okay? If I go ahead and the compile section, if I go to the deployment section, which is what this is, by the way, make sure in the compile section here, make sure you have auto compile on, which is very, very important. And then go to the deployment section. And in this section, what I want you guys to do is deploy the smart contract. And now we're just going to deploy in the Remix London right here. So let's go ahead and hit deploy. Okay. Let's see what happens now at this point. Beautiful. Let's see. By the way, guys, while we're waiting, make sure to hit the like button, the subscribe button, whatever you gotta do. That really helps us out and me out. I want to keep growing this community, and so forth. So make sure, stay tuned for more videos like this. Awesome. We deployed our contract, as you can see right here. Here's our contract right here, right? So let's go ahead and scroll down. Make sure you open this up. We have all these functions you can see. You might be wondering, you're like, Nas, where is these functions coming from? Was this like some mix-up? Is this a black box? No, not a black box, just so you know, okay? Not a black box at all. Actually, all these functions are defined directly in the ERC 1155 smart contract. So if you go to like ERC 1155 GitHub page, right, which shows you the actual code, all the functions like balance off, like for example, right, the balance off function. Let's look at back in Remix. Balance off right here. See right here. Balance off function, right? So all these functions are defined in the ERC 1155 smart contract, and that is what's actually allowing us to see these NFTs, because technically we are doing what? We are importing this smart contract into ours. to test out the mint functionality, let's try to hit mint. Of course, you specify what ID you're trying to mint, or let's just say we're going to mint the first ID, which is usually what? 0. Mint ID of 0, that's the NFT ID. And the amount, how many? Let's just say 1 for now. If you hit transact, it says wrong, not enough money sent. To fix this not enough money sent is because we need to actually send money through Remix in our case, kind of like MetaMask, I want to call it. We need to pass in 0.01 Ether into this value section, and then that's how we pass in money. But if I select Ether here, you will notice that I cannot do 0.01 because it only takes in whole numbers. You need to understand that whole numbers don't really work very well. As you can see here, when we add the value portion, we can only add whole numbers. So we need to convert Ether converter. Wait, that's right. You see, this is this much Gwei and it's this much Wei. So it's like smaller units, right? Right now, I'm just going to use Gwei. Why not? I will hit copy on this one, hit Gwei on this one. Go back to Remix, type in, select Gwei and paste in my Gwei. And now let's hit transact and look at that. It's pending and it's minting our NFT and it's actually working, right? So we got the green check mark right here. And we can actually check the total supply right here. If I check the total supply, where is it? Total supply of the ID of 0, it should say 1 because only one person minted the NFT. Does that make sense, everybody? Beautiful. Okay, but here becomes the problem. What if I want to mint 3, right? Let's just say I want to mint 3 NFTs. Okay, what happens then? Well, I'm going to pass in my value of 0.01 Ether. Beautiful. And I hit transact. And look at that. It's actually transacting. It's actually transacting. It's actually minting 3 NFTs for the price of 1. And that, my friends, is a no-go. That is a no. No, that I was trying to make it funny, but I really don't know. Don't have that boo sign, basically, right? So what we want to do instead is we want to require price in the right way. And how do we do that? Well, think about this. If we want to buy 3 NFTs, what should the price be? 3 times the price. If you want to buy 4 NFTs, what should the price be? 4 times the price. So that's going to be our goal right here, is as we're buying here, we're passing in how many NFTs we want to buy. Let's just say 4 or 5, whatever it might be. I'm going to say here, public price, it should be the value of how much money I'm passing in should equal to public price times amount, right? So 0.01 times 3, 0.01 times 4, 0.01 times 5, whatever it is. And now it will probably calculate the price for us. That's right. So if we go ahead and exit this part, deploy it one more time. It's deployed. Again, make sure when you deploy, make sure you exit out the past smart contracts, hit deploy on this one. And if we try to hit mint at 0, right? Let's just say we want to buy 2 of these and we pass in this exact same amount of 0.01 ETH, right? Let's do that right here. Oop. Boom, right here. Right, Gwei. It will tell us not enough money because we need to pass in 0.02 ETH, which in our case is how much? How much? It's 2, whatever this is, but 2, right? So now if I transact that, we'll see, oh, I guess not enough. Let me see, 0.02 ETH. So let's go ahead and remix here. Boom. Let's go ahead and hit transact. There we go. You see, now it went ahead and it went through, right? Because we passed in 0.02 ETH off that. Does that make sense, right? So there we go. So now, as you can see, we're requiring payment in the right way. The most important part, okay? Moving forward, let's talk about the supply, right? So let's make sure we add supply tracking, right? And what is supply tracking for those who don't know? I want to see in the comments, guys. Supply tracking means that, well, if you look at Adidas here, for example, the amount of NFTs there are in total is how much? Let's look at this NFT here. It says the total, it's 5.8K total, right? That means there's only 5.8 thousand of these NFTs. Well, technically it's one NFT, but, you know, 5.8 thousand versions of the same one, I guess you can say it that way, right? So 5.8 thousand here. So how do we make that limit? It's the same as like when you go to, I don't know, like a Bored Ape NFT, for example, right? There's only what, 10,000 NFTs in general, right? The items is 10K right here. Right now, I can mint as many as I want. 1 million, 2 million, I don't care. So we need to add that supply. And to do that, again, we need to go ahead and create a requirement. So say require, right? Which is like some kind of a current supply should equal to, it's like a current supply is how much do we have so far right now, right? Just how many have been minted so far for this specific NFT should be less than or equal to what? The max supply. So our max supply, let's go ahead and define that. So we say uint 256, we say public max supply is gonna be equal to, let's just say, I don't know, maybe it's like, let's just say for now, it's actually 1. I'm gonna like make a small number so we can probably test it. Let's just say max supply right now is 1, okay? And you wanna make sure that it's less than, the current supply should be less than the max supply right here, right? The question becomes is, where do we get this current supply function right here? And what we can do is very, very simple, guys. And there is a function in the smart contract, the total supply smart contract, and it looks a little bit like this here. If I can show you here, ERC95 supply here. Boom, 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 boom. Boom, 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 right here. Okay. You'll notice here that for the ERC11 supply, no, not the one I'm looking for. Let me see here. Let me make sure. I want to show it to you guys where this is all coming from, because I want to make sure you understand that it's not coming from nowhere. Right here. Beautiful. Right here. We have the total supply function, which is total amount of tokens in with a given ID. So it's how many tokens have been minted so far. That's what that gives us. Okay. So if I go back to my remix, we're going to use the total supply function, and we need to pass in for which ID. Because remember, we can have different supplies for different IDs. You know, for the ID of 0, it could be one ID. For ID of 1, it could be another ID. So in my case, it's going to be for whatever ID we pass into the mint function. And that total supply, which is, again, it's current supply. It's just, I think the name is wrong, basically, right? Should be less than the max supply, okay? So we'll say here, again, going back to the supply section, right? Is the current supply less than max supply? But remember, if we're minting 10, let's just say, we need to add that to the current supply. We need to say total supply plus amount should be less than max supply. Because if you think about it, let's just say the current supply is 0, okay? Just give you some ballpark here. Current supply right now is 0. Okay, what do we do now? And I want to mint 10. If I have this, then technically this is true. 0 is less than the max supply of 1, right? 0 is less than 1. And so I can mint 10 because I say I want to mint 10 here. Does that make sense? But in order to prevent me from doing that, I can say I have to add however much I'm trying to mint to the total supply right now, and then check that. And now I can say, if this is wrong, I can say here, sorry, we have minted out. There we go. Right? It should actually be less than or equal to max supply. I'm sorry, guys. This should actually be less than or equal to max supply. So if max supply is 1, then we should be able to mint at least 1, basically. Yeah, that makes sense. That makes sense. So I have to go ahead and change this from less than to less than equal to sign. Okay, and let's go ahead and redeploy our contract one more time here. Again, if I try to mint 2 here, let's try to mint 2 right here. It should give us an error with an ID of 0. Mint 2 with a 0.02 ether, of course, which is the right amount of price. Let's pass it into here. Boom, hit transact, and it should tell us, sorry, we minted out, not enough NFTs, right? You cannot buy anymore. Beautiful. But if I try to mint 1 with a 0.01 ether price, of course, that should work. So let's try this one more time. Boom, transact. There we go. You can see we made a 1 NFT, and that allowed us to actually do it, which is amazing. Moving forward from this, we've got the max supply. We've got the public price, right? Let's now make sure that we mint only a certain ID, because let's just say here, right? Let's just say if we go back to our Adidas originals, okay? As you can see here, we only have how many NFTs? We have, right, 0 ID of 0, right? You see, if you look at this 0 portion, it's an ID of 0, and also an ID of, I believe it's an ID of 1 as well. So ID of 0 and 0 and ID of 1. So we need to make sure that ID is less than 2. Let's go ahead and add that into the smart contract. So we say here, hey, require for the ID to be less than 2, and say, sorry, looks like you are trying to mint the wrong NFT. To mint the wrong NFT. There we go. Okay. Awesome. So look at this. We've got the ID. We've got the message value. We've got the total supply. All right. And let's see what this actually looks like. Okay. And what I want to do now at this point is run this function. Look at my, deploy the smart contract. Look at what we can see in OpenSea, and then go from there. Let's go ahead and deploy our smart contract here. Deploy. Boom. Let's go ahead and mint our NFT. Awesome. Of 0. Amount is going to be 1, of course. And let's pass in that our correct number of, there we go, 0.01 ether. Pass that into here. So yeah, you have to hit backspace sometimes in order to pass that in, and hit transact. There we go. We minted our NFT. And now let's check what is the URI we're gonna get from here. And you'll actually notice here, if I get the URI of the ID of D of 0, kind of does nothing. It just kind of gives us the original URI, right? So we need to kind of fix that part, because we need to be able to IPFS, we need to be able to get 0.json part. Without this, you know, if we just get this, it doesn't really know what NFT to showcase to OpenSea. Does that make sense, everybody? Doesn't really know that. So we need to tell it that. We need to set up the correct URI function to tell it that, okay? Again, let's go click on the contract. And to fix that part, let's go back to our OpenZap on ERC-NFT5, right here, ERC-NFT5 Solidity. And let's look at the URI function. URI, say URI, of course, boom. We have a URI public view. So this is the URI function that actually, you know, just simply returns a normal URI for us, right? So what we're going to do is we're going to copy this section right here, this public URI, and put it into our smart contract. We're going to override this URI function in general, right? Override returns to member. So the first thing we're going to do is we're going to check, hey, is this URI, is the ID that we pass in, UN56 ID right here, is the ID that we pass in, is it, does it exist? We say require that it exists, the what? The ID. Let's go make sure this is underscore ID. There we go, exists underscore ID. So basically, we want to check if the ID exists at all in this smart contract and go from there, okay? Because if it doesn't exist, then we can just say, comma here, right? URI non-existent token. If it does exist, though, we need to combine the current IPFS, a URI, with the ID and with the JSON. So I have this right here, this part for you guys, that you can copy and paste it for you. So just make sure you look this up on your end. Here it is. Here's kind of how it looks like, right? So what we do here is we do return. We convert everything into a string, and we use the API, the encoded packed. I know it's a little bit kind of wacky, but this is what combines different strings together, right? We're going to take our initial URI with the current ID. We're going to return that, combine that with the current ID of the NFT, so like 0 or 1, and then combine that with JSON. And yes, we do have an error here because we need to import strings as a import statement here. So let's go ahead and make sure we import our strings, and the way it kind of looks like is like this: import open Zemplin contract utils strings, and that allows us to convert numbers into strings. Got it, guys? And there we go. So now we have this URI section, right? And we return the .json with it. And that's actually pretty cool, because here's why, guys. Here's why. Let's go ahead and try to deploy it, right? Deploy it normally as we usually do. Boom. Let's mint our NFT as we usually do. Okay, amount of 1. Let's copy and paste that GUI part. Amazing, right? Let's go back to remix here. I know this is a lot, guys, by the way. Transact. Okay, minted an NFT. Beautiful. This is a check mark. Let's scroll down. Let's go to our URI. Go to 0 for the URI. Hit call and check this out. You see this? 0.json. This part is exactly what we are looking for, because this gives us the actual JSON for the NFT. And here's the JSON I'm talking about. So if I copy this whole IPFS and I put it into my link here, I'm going to remove this because this part is just like a shorthand for the actual IPFS link. I'm going to say IPFS. I have this IPFS stored somewhere here. There we go. Right? If I hit enter, there we go. See, we've got our NFT for Web3 builders. External URL nazweb.com. Let's go. This is the link to the image itself, the name, the description, and then some ads. So now the question becomes, do you guys want to see this on OpenSea and see how it looks like, just so we have an idea? I think so. Let's do it. Let's do it. Let's do it. Let's do it. So if you want to see this on OpenSea, we are going to, instead of hitting deploying smart contracts here, we're going to deploy using MetaMask. To do that, guys, you have to make sure you have MetaMask on here. There we go. You have to make sure you are using Goerli test network, which is what this is. If you don't have the Goerli test network, guys, make sure you go to show and hide test networks and make sure this part is on. Okay. And then go to Goerli test network. Okay. And make sure you have Goerli test ETH. You can see I have 0.4 test ETH. And then for you, make sure to get the test ETH, just go to Goerli faucet. Goerli faucet. There we go. Right, and then you can actually put in your wallet address to actually sign to get free 0.1 Goerli ETH per day. So once you've got that, then let's go back to our remix And let's go ahead and start doing our environment of VM London. We want to select what? Injected provider MetaMask. And you can see it says Goerli 5 network, which is exactly whatever I have in my MetaMask. Right there. See? Awesome. Now let's go and try to deploy this smart contract and see what happens now at this point, okay? I'm going to hit deploy. It's going to ask me for a MetaMask. I'm going to hit confirm. Beautiful. Let's view this on Etherscan. So you can see on the bottom right here. Okay, so let's go ahead. We've got the contract deployed. Let's go look at our contract. Here it is. We've got the contract created, right? We can actually now mint our NFT. So let's try to use Remix to mint your NFTs. You should see your contract inside here. Let's mint your NFT. Select an ID of 0 and mint an amount of, let's just say 1. Of course, because we can only do 1 right now. Let's go and pass in that, whatever, how much this, 1 million or 10,000. I'm not sure how much GUI that is. But pass that part in. Boom. And then hit transact. And then hit confirm. You can see as it actually asks me for my MetaMask account, which is exactly what we want. Hit confirm. View on Etherscan. And hopefully it's going to confirm our NFT right here. And here's why I'm doing this, because I want to show you guys that it actually works on OpenSea. That's right. Hopefully this properly. Yes, we minted an ID. You can see right here, ERC 1155 of token ID of 0 was minted. So now how do we see this on OpenSea? Hey, how's it going? This is Nas from the future, and I'm going to show you how to view this on OpenSea. Now, what you want to do is, as you can see right here, this is your smart contract address, and you just simply want to copy this smart contract address and go to Google. We'll just open up a new tab and type in OpenSea testnet, like so, and click on the first link you should see. And all you gotta do is paste in that contract address. A lot of times it just shows up. Sometimes it doesn't. If it does not show up, just hit enter and you should still see it in the collection results. If it still does not show up, just give it some time and it will show up maybe after like 10 minutes or so, okay? Beautiful. Now let's go ahead and click on the collection and there we go. There's your Web3 builders, of course. I know I'm using doodles just for educational purposes. Don't yell at me. Don't be mad at me. I'm not trying to copy any NFT. But as you can see, that says owned by you, Web3 builders number 0. That's the JSON data for it. And here's the attribute for it. And that's it. There is a way for you to view it on OpenSea. At this point, we've got the main functionality, right? We've got all of that. We're passing in the value. The question becomes is now, as you can see, as we pass in money into the contract, we have this balance. All this data, we're passing in money. Now, as you know, whenever you pass in money into the contract, as you can see, the balance of that money gets stored where? Directly in here, in the balance. So we need to create a withdrawal function to be able to withdraw that money, right? So we can say, hey, transfer this money that we just got from the mint into my own smart contract, So we will go ahead and do that right now. So let's go back to Remix. We'll create a withdrawal function here. And that's actually a withdrawal function you can find anywhere on, smart contracts. For example, if you go to OpenSea here and you type in these guys, which are really cool, by the way. Let me see here, OpenSea here. If you type in Nifty Portal, right? If you type in Nifty Portal, if you look at some of the, for example, this is how I learned how to do smart contracts. If you go to details here, if you go to the contract address, if you go to the contract side, you actually find a withdrawal function, withdraw inside here. And it's the same withdrawal function that actually a lot of contracts use as well, right? All I have to do is just copy this contract. It is an MIT license, right? So, it is open source license because everybody pretty much uses the same exact thing. And we're going to copy this directly into our smart contract as well, right here, right? If you don't want to copy on your end, you can just do it on your end, guys. And here's what it consists of. I'm going to explain this really quickly here. Basically, withdrawal function allows us to withdraw from the smart contract. This is the address we want to withdraw to. What we do first is we get the balance. Get the balance of the smart contract. So let's just say 1,000 people minted, they give you 0.01 ETH. You've made some good money. Time to withdraw that money into your wallet so you can use it for, to continue building the project out for your team, stuff like that, right? Then what you do is you set this address to be payable, and all you do is just transfer the money like this. You transfer however much the balance is of the current smart contract into this address. But then you might be asking, hey, no, can't anybody just do that? Is it true that they could just add in their own wallet address and just pass it in? Well, not necessarily, because only the owner of the smart contract can call this function, nobody else. I want you to understand that. Only the owner of that smart contract can actually call this function. Nobody else can call this smart contract, okay? So really, really important for you guys to understand that part. And then to show you an example here how this works, okay? Again, let's go ahead and try to deploy the smart contract again. Let's just go ahead and try that right now. So I'll hit deploy. I will hit deploy. Actually, before we deploy, guys, let's change the supply to be 20, just so I don't have to play around with this kind of stuff. Make sure to change the supply to be 20. Let's go and hit deploy, hit confirm. Awesome. All right, looks like I think we're pending right now. I think we're pending. Let's go ahead and run a Goerli test network. The reason I'm doing this is because when I was learning smart contracts, I could not find this in like one specific tutorial. There's a bunch of these tutorials that are all over the place, you know, and you have to go looking for a bunch of different things to create a smart contract. But the smart contract that I'm teaching you is the same features we add to our clients, right? Whenever we work with an NFT project. We add all these features, of course, so we change things up. It's not like a copy and paste solution, it never is, but the general idea of it is the same, right? So I want to make sure you guys understand that part, right? So you can actually apply this to your own world and to your own clients. Contract has been created. Awesome. Let's go back to our remix. Let's go ahead, go to our smart contracts and mint our NFT. So let's go and mint an ID of 0. An amount of how much? An amount of 1, let's just say. Again, let's pass in that way of whatever much it is. There we go, into the value section. Beautiful. And just hit transact and hit confirm. So we went ahead, we deployed, we minted our NFT right here. So now if you look at the contract, you'll find this, a balance, meaning there's a balance of 0.01 ETH. But imagine you can have a balance of 1,000 ETH, 100 ETH. So the question becomes is how do we transfer this balance directly into where? Into us, right? Directly to who the creators of the project is. So we can actually use that money later on for other purposes, paying the team and stuff like that. What you can do is, let's go back to our remix section. And what we can do at this point is hit withdraw, you see, boom. I will use my MetaMask wallet right here. I'm going to say, go ahead and copy to clipboard, MetaMask wallet withdraw function right here. And I'll pass in the address of just my address, right? So I'm going to withdraw the money to my address. So you can see right now we have, why do I just keep getting all these stuff? 0.367, right? So if I hit withdraw and I hit transact, I want to hit confirm and let's see if that actually works. Remember the 0.067, right? 367. Let's try to figure out if this will actually change. This should change to 0.37. Let's see. Look at that, 0.37. So that money has been transferred directly into me. And the reason why I could do it is because I'm the owner of that contract. You can see here, right there. And if I go back to the contract, you'll actually notice that now it has 0 ETH because that money has went from one account to another account. Does that make sense? Hopefully it does, guys, okay? So we've got that portion. We've got the withdrawal function that looks really good. The next section I want to talk about is going to be the allow list functionality, right? Which is really, really important, is creating that whitelist, or nowadays we call it the allow list. So the people who are hardcore fans of the project can mint for a cheaper price. You know, they have certain, functionalities, probably some special requirements, all that stuff. So let's go ahead and do that. What I'm going to do right now is I'm going to create another function and call that a allow list mint, right? So I'm going to say function allow list mint. Same thing. I'm going to pass in the ID right here. And then it's going to be a public function, and that's pretty much it. It's going to be a public function that does all of this stuff, right? And of course, it has to be payable, as you guys know. Make this a little bit smaller here and make the text a little bit bigger. Public, make sure it's payable, meaning we can actually pass in money into it. But the allow list function, we're probably going to require a different amount. We're probably going to say, hey, maybe your price is cheaper versus the public price. So let's go ahead and do that. So here we'll say public price might be 0.02 Ether, while allowment price, I guess we call it, would be that. So let's go ahead and do UNT 256, public allow list price is equal to 0.01 ETH, right? So this is a different price for the people who are part of the allow list. And so now what we can do is that we can require that inside here. So inside here, I'm going to say allow list means going to be require what? Require the message.value should equal to what? Should equal to allow list price, I guess. Yeah, allow list price times the amount. And of course, we're going to mint this stuff inside here too. So we're going to mint this NFT inside here as well. And this is how we're going to require the payment. Okay. Same thing. We also need to make sure we keep track of the supply. So that still gets copied over. And we need to make sure we're tracking for the ID as well. Make sure that's copied over as well. Okay. And now let's go and change this mint from a mint to make that into a public mint, right? Because now we have two different mints. We have the public mint and then we have the allowlist mint. So two different mints that we want to make sure we set forth. Okay. How do we know which mint is open? Because technically right now, I can mint either through this function or I can mint through this function. I can choose. If you look at whenever we deploy this, let's just say if we deploy the smart contract, let's just, again, let's not use the MetaMask because I want to test this really quickly here. If I do deploy really quickly here, technically I can mint both public mint and allowlist mint and nothing is stopping me right now. What I need to do is I need to set some variables to say, hey, currently the allowlist mint is open or currently the public mint is open. So hopefully that kind of helps you guys out on that part. So let's go ahead and do that. I'm going to create two different variables and call them allowlist open and then public mint open. Let's go ahead and do that right now. So say here public boolean, because it can be boolean here, or bool public. I'm going to say here public mint open is going to be equal to false. And then I say here bool public allowlist mint open is going to be equal to, let's make that true for now. Right? That's the first one that mint is going to be open. Okay. So basically, if this is open, it means we're good. If this is open, it means we can use the allowlist mint. And so we can use these variables now to figure out, hey, which function are you actually allowed to use? So in the allowlist mint, we're going to say, hey, require that the allowlist mint open is true. Boom. Mint open should be true. Otherwise, basically, we say here, if it's not true, that means what? Hey, we're not open yet. I mean, the allow list is closed, right? That's what that means, guys. So that's what we say here. We say here, allow list mint is closed. This means only when this is open, then you can mint, right? Let's go back to the public mint now. We say here, require public, oh, no, I said this wrong. Public mint, I think it's called open. I believe so. Otherwise, we say public mint closed. And that's pretty much it, right? So this is how these projects, whenever they mint NFTs, they have the allowlist mint, they have the public mint. This is exactly kind of what they do to make sure they keep track of this kind of stuff. Now, you're like, Nas, okay, so that means we set these variables. Okay, but what if we want to change these variables? Good question. What we need to do is we need to be able to create an edit function. Here. Let's go write this down. Create an edit function that will edit the variables, the mint windows. And so what we can do at this point is just create an edit mint windows here. So let's go and do this right now. So we say here function edit mint windows. Boom. Inside that, we are going to pass in two things, right? Two things we're going to pass in. The first thing we're going to pass in is going to be a boolean that's going to be a underscore public mint open. Why? So we're going to say, hey, this point in time, now the public mint is open, or at this point in time, now the allowlist mint is open. And then we say bool underscore allow list mint open. Beautiful. Okay. We have this error right here. It says no visibility specified. Okay. So we need to specify this is going to be an external function right here. And external means, by the way, but those of you who don't know, external means that only the external functions can call it. You cannot call this function internally within the actual contract. That's what that means. And people do that because it does save on gas fees. So if you don't need to call this function within the actual contract, just say external basically. And one thing you want to make sure is who can call this function? Oh yeah, anybody call this function. No, only the owner can call this function. We say here only owner can call this function, because otherwise people could just change their own windows and that just makes no sense, right? Which is no bueno, which is no good at all. So we say here only owner, and at this point we say here now whatever the owner passes in, that's gonna be what's set. So we say now public mint open is equal to what? Underscore public mint. Boom. Now we say allow list mint open is equal to underscore allow list mint open. So we're taking these variables, we pass it into the function, into the contract, and passing them directly and setting them in the actual contract itself. All right, beautiful. There we go. And so now only certain people at certain times will be able to mint their NFT. And that is perfect, right? That's exactly what we are looking for. Moving forward here, guys, we're not done yet. We still have a good amount to go. This is, by the way, a very long smart contract, but that's perfect because this smart contract has everything you pretty much need in general to launch an NFT in general. So let's go ahead and go to our edit mint windows into deployment section, and let's test this smart contract out with the editing of the mint windows, right? I'm going to go ahead and hit deploy, remove my previous one, and here's my new one that we just deployed. Beautiful, awesome. Let's go and do this. So as you can see right now, only the allow list mint is open. If I try to do public mint, let's go and try and to do, let's go ahead and try to pass in some money like this right here. For public mint, we need to pass in 0.02 now, right here. Amount of 1 NFT, pass in that gray amount, and hit transact. And it says public mint closed, which is perfect. But if I do allow list mint, so I do 0, I get amount of 1, and I have to pass in this time 0.01 ether instead of 2. So copy that portion, go back to our remix. Let's go ahead here, paste this in, and now hit transact. Boom, see, that part went through. And it minted our own NFT, which is exactly what we are looking for. Right now, what happens now, the issue becomes that, well, now at this point, still anybody can technically mint this NFT, right? At allow list mint. If this is open, there's no requirement on the address of who can mint and who cannot. Anybody, if you guys are watching on YouTube, you can call this function and just mint your NFT. And then you're like, hey, why should I use this function? This function requires more price because the public price is 0.02 ETH. Why not just do this allow list mint function and get it for 0.01 ETH? Well, this is where we actually need to store the people who are part of the allow list. And that part is really, really important, you guys, okay? Let's go ahead and add that part in. And how are we going to store this data? Well, we're going to store this data in something called a mapping, which is really, really cool because a mapping actually stores key value pairs. So we're going to store a key value pairs from an address, right? So let's just say we have an address right here of like 0x blah, 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 store to, and this is true. True means it's part of the allow list, okay? So it's going to create that mapping here. Mapping, I'm going to say here, it's going to be from an address down to what? Down to a Boolean of what? Of the allow list. There we go, right? So this is where your addresses will be stored in terms of who's going to be able to mint using the allow list. All right, beautiful. Awesome. But of course, now we need to set that allow list. So we need to create a function to set the allow list. So let's go ahead and do this. Create a function to set the allow list. And what we're going to do is we're going to pass in a list of addresses, almost like an array of addresses, into this function and then create it that way, okay? So how do we do that? Well, there's a function called, like I said, set. So let's go ahead and do that. Let me go ahead and make sure I have it properly done. So like I said, let's go ahead and do function here. Set allow list. Allow list, all right? We're going to pass in an array of addresses. So we'll say address, an array, call data, addresses. Okay, it's an external function. And only the owner should be able to call this function, right? Because otherwise, that's pretty bad, right? Otherwise, it's like everybody can add themselves to the allow list, which is not good. We're gonna loop through every single, right? Through every single address. Just gonna do for loop. I'm gonna say uint 256 I is gonna equal to initially from 0. We're gonna loop through every single one and add it to the mapping here. I should be less than addresses dot length. There we go. And we'll say I++. Like a normal loop. You guys should probably remember this. We're gonna say the whitelist now, or the allow list, which is that mapping, at the address, which is the addresses I. See this addresses? Addresses of I, there we go, should equal to true. So this is how we are going to add these addresses to the actual mapping itself. It's going to loop through the addresses and add the address, individual address, with a value, a key of the address and a value of true. And the reason why we do this is because after we've added this, we can actually check it now. So in the allow list mint, we can say here, require that the message.sender is actually in the allow. We say allow list, and the message.sender is actually in it. Otherwise, if he's not in it, then we say you are not on the allow list. Simple as that. You are not on the allow list, right? And this is how we check if you are on the allow list or not. So let's go and deploy this and actually see how this works out. We are going to pass in that 0.01 Ether, and it should give us an error. That's the goal here. It should give us an error. So let's go ahead and do that right now. Let's paste in our value, which is how much money we're passing in, and hit transact. And yes, it does give us an error because it says you are not on the allow list, which is correctamundo, right? Because we are not on the allow list, but we can put ourselves on it. So check this out. So we now say, we go to here and we go to set allow list. You see this function set allow list, and we're going to pass in our current address, my current MetaMask address, which is what this one is, right? This one right here. I'm going to pass it in as an array into a string like this and hit transact. And there we go. So now it's saved basically if we're on the allow list or not. And if you hit this allow list portion, you'll see it actually says true because we are on the allow list right now. So let's go ahead and try to do mint allow list mint one more time. And this time it should be what? It should let us through. That's the goal here. Pass in our Ether value, right? So let's go ahead and push that in. So again, let's go and add that value in 1000 allow list right here. So let's go ahead and do a transact. Says you're not on the allow list. Oh, they are not the allow because I added the wrong address. Technically, guys, we're actually minting with this address. This is this makeshift one. So we need to copy this one. This is my fault, and add that one to the actual allow list. So copy that one, hit transact. There we go. And now technically we should be able to. Let me try this one more time. Let's pass in our GUI into here. Boom. Hit deploy. Hit transact. There we go. It all went through. You can see now because I added myself to the allow list, I'm all good. I can actually mint this NFT. Does that make sense, everybody? Hopefully it does. Okay. Right. I just had to make sure I actually pass in the contract address or the wallet address of this one, because we're not using MetaMask right now. We are using a private blockchain through Remix. Okay. Yeah. So that is what's going to allow us to mint through the allow list right now. Moving forward, I want to show you kind of like what happened if I, edit the mint window. So if I go to the edit mint window section, I can say, hey, public mint now is going to be true, and allow us mint open is going to be false. I hit transact. As you can see now, that's good. And if I try to do allow list mint again, it actually won't work because you'll notice that it's actually not open. So if I go to try and mint this one more time here, if I pass this part in again, oops, and I hit transact on the allow list mint, it should tell me an error, allow list mint is closed. I do want to clean up some of my code here, guys, because right now it's a little bit messy. And why? It's because you notice a few things, right? What do you notice here? You notice here that we have this right here, complete copy. This right here, where was it? This complete copy, right? And this complete copy. So I want to extract these out into its own function so we don't have duplicate functionality going on here. What I'm going to do is I'm going to create another function called mint. That's going to be passed in it's going to pass in the ID also, right? UN256 ID and the amount right here. And it's going to be not a payable, it's going to be an internal function, right? So only we can use this function internally. Inside here, I'm going to copy whatever we do that is a duplicate. So for example, this we do in both public mint and whitelist mint, right? This we do in both public mint and allow list mint. Awesome. And then one last thing that we do in both is what? The ID check, right? This one right here. Same thing goes here. Boom, right? So I can now remove this part, remove this part, remove this part from the allow list mint as well. Again, this just keeps it so much simpler, right, guys? So much simpler, right? And only use functionality that is necessary for that function. And I'm going to use the mint function instead. Right here, see? Same thing goes here. I'm going to use the mint function instead. So we have whatever specific that function we have that's inside here. And then the rest is basically, it's a duplicate. So we'll just put it into its own internal function. Hopefully that kind of clears some things up for you guys. Okay. Beautiful. Next thing I want to do is let's go ahead and make sure that we have a max per wallet. So let's go ahead and do a max per wallet. So let's do uint public max per wallet. Let's maybe do what? How many should we do max per wallet? I don't know, 3. Let's just say here. Awesome. To make this max per wallet work properly, like I said, we save that, and then all we have to do is just simply check it later on. We have to save it like almost like a transaction, you know, in terms of how many you're actually allowed to mint for every single one. So what we can do, we need to actually save however, basically what is the balance that people have. So whenever we mint an NFT, first thing we do is to save that data, right? Is whenever we mint here, let's go and save that data and start somewhere inside here. It's like, hey, you know, this person has minted this many NFTs, right? And to do that, we are going to do a purchase. So purchase, let's call it wallets, purchase per wallet, purchases per wallet. We're gonna save into a message.center into whoever is calling the function. I'm gonna add in the amount, so plus equal to amount, right? And again, this is going to be a mapping as well, right? So I'm going to save this in a mapping too, as well inside here. So we'll say mapping, going to go from address to what? To a uint 256, right? And say, and it's going to be purchases, again, purchases, right? So we have this data, and every time somebody mints, we make sure that, right, we add that into the purchase per wallet, right? So we keep track of, hey, if you minted 10, we will know it's 10. If you minted already 15, we know it's 15, right? And the max we're allowed right now is only 3 right now. And so what we're going to do right now at this point is in the mint function, I'm going to require that. I'm going to say require that the purchase per wallet of the message sender should be less than or equal to plus whatever the amount we're trying to buy. So if we're trying to buy 5, right, should be less than or equal to the max per wallet, right? Otherwise, you know, we can say, hey, wallet limit reached. There we go, right? And so this makes sure that, hey, we can only buy, so we can buy 2 or 3 NFTs per wallet. Does that make sense? Hopefully that kind of makes sense to you guys. And that's how we added the limit inside right here. Okay, public mint. And it's, again, it's on an internal mint because why? Because this is something that's duplicated around public mint and the allowlist mint. Does that make sense, everybody? Hopefully it does to you. Okay. And we can actually now test this as well. So let's go ahead and test this out. If I'm going to try to, let's just say, mint a few NFTs using the public mint, you'll see that it will actually give me a wallet limit, right? Let's go ahead and try that right now. And let's go ahead and remove this portion. Let's go ahead and hit deploy. Awesome. And let's try to mint right away 4 NFTs. Let's make sure we have, let's change this to up to be where the public mint is going to be true, while the allowlist mint is going to be false, because we want to use the public mint function right now. Okay, awesome. With the public mint, if we want to mint 4, we say ID of 0, amount of what? How many? 4. And what is the ether? 0.0 what? 4. I believe it's actually 0.02 times 4, so it's actually 0.08 ether. Because as you can see, we are requesting how much? 0.02 ether per public price. We need to pass that part in. Boom, 8 right here. Awesome. Let's go ahead, transact. And it should say wallet limit reached, because you're trying to buy more than what you're allowed per wallet. But if I try 3, and if I pass in 0.06 ether, that's going to work right here. Let's go and pass that in, 0.06 ether, hit transact, boom, we've got now our, 3 NFTs per wallet. And at this point, guys, that's pretty much it, guys. So we have gone through everything we need to go through in terms of, I would say this smart contract is very complex at this point, has so many different functionalities. You can actually take this to your clients now and actually apply this, right? This is kind of what we do, but we do it on a bigger scale a little bit with our company. And for those of you, by the way, those of you who are interested in launching your own NFT project, maybe you're a company or brand, that's what we do pretty much. We'd love to help you guys out. If you are interested, we have a link down below to go ahead and schedule a call with us so we can figure out how we can help you, okay? I'm not done yet though, because the next thing I want to do is a payment splitter. What if I want to be able to split up payments, right, across my whole team? Right? Let's say that you I know you launched an NFT project, you guys made $1 million. Okay, again, I know hypothetically, and 10% goes to developers, 10% goes to designers, another 10% goes somewhere else. How do you ensure? How do you do in a way that's trusted that money can be split up evenly across the team? And that's where something called payment splitter actually comes in. So check this out here. So this is so cool, by the way. You have to listen to this, okay, guys? So we have a payment splitter function on GitHub, Open Zeppelin here. And this actually splits up the payments of the NFT. So you can actually release. So if it's 10%, it will release 10% of the mint, right? And you can release these funds depending on how many shares. It's like you have shares of the company, and depending on how many shares of the company you have, you get that money back. So let's go ahead and try that right now. Let's go ahead and do a payment splitter right here. To add a payment splitter, we need to, of course, import it. And how do we import it? We import it directly from the contracts finance section, right? So I'm going to do that right now. Let me go ahead and do that right now here. So I'm just going to copy this whole section here. And here it is, right? So import from Open Zeppelin contracts, finance, and then payment splitter.sol. Hopefully you guys can copy and see that, okay? Now, at this point, we need to include this as part of the contracts. We say is apply, and then we say payment splitter right here. And you need to define the payment splitter actually on the constructor, and that's really cool as well. So to do that, you'll see here, I'll show you here in a second here. So we say ERC-5 supply, but also we say here payment splitter. And this is really cool. This is where you define how many shares actually is passed in and then what are the payees. Pretty crazy here. So I'm going to say here in the constructor, I'm going to pass in who is getting paid and how many shares each person has. So let's just say here an example here. This is my account. So I'm going to say here address. This is an array of addresses, memory, just temporary memory of payees, underscore payees, right? This is who is the owner of this NFT project, right? It's who is the owner of this NFT project, okay? So that's the payees. It's who's going to be paid out. Now, the next thing we need to do is how many shares does each person have? So I'm going to say here UN256, an array of this, memory, and underscore shares. So let's just say I have 10 shares and then someone else has 90 shares. That's 100 shares, means I get 10%, someone else gets 90%. Hopefully that makes sense to you guys. And that gets passed into the constructor through the actual deployment script. And then we pass that in directly into the payment splitter, payees, comma shares, underscore shares. And this is how you split up payments off the smart contract, which is so cool. Now, usually at this point, you would remove the withdrawal function. I'm going to keep it there for now, but usually at this point, you would remove the withdrawal function because the payment splitter is what allows you to withdraw the money. So let's go ahead and test this out because I do want you to see this and it's really cool. And you would be excited to actually see how this works properly. Let's test this out. I'm going to hit compile. Of course, make sure you compile your NFT, compile my NFT. Let's go ahead and hit deploy now at this point. And we're going to deploy using our MetaMask wallet. So let's go ahead and remove all this other stuff. We don't need this. Let's deploy using our MetaMask wallet right here. Okay. Now, it says, you see, when you deploy now, you have to specify who's the constructor arguments. In our case, it's going to be 2 payees. So we have 2 payees. One is going to be me. Let's just say I get 10%. So here's my MetaMask wallet address. This is my 10% right here. Boom. Right. And then the other person is going to have the 90%, which could be potentially, the founder or someone else. So let's go ahead and create another account here. Maybe account 2 here. Why not? And this is 0848. Okay. Again, put that into the quotes in the array. You can see here, these are the 2 addresses that we have saved right now so far. 848 and 57. And the same way, you have to specify how many shares these people have. So the first array ID, right, of token ID 0, it's going to be, I have 10 shares versus that other person with the address of 848 will have 90 shares. We don't need this to be in the quotes actually. So comma 90. And let's try to make this work. And let's go ahead. Let's go back to our original account 1. Awesome. Let's go and hit transact. All right. So we're going to deploy this contract. I like it. All right. Let's see what works here. And weirdly enough, where I learned from this, I learned this from the Adidas originals. So this is how I learned smart contracts. Actually, you'll actually find as well. So if you go to details section here, in their contract address, in the Adidas originals one, you actually notice that they have a payment splitter on their side too. Right here, see? That's where I learned it from. Public information, guys. Public information you can just use from anywhere. Contract has been created. I love it. Let's try and mint our NFT, guys. You ready? Here's our contract. Let's mint our NFT. So right now, I believe only the allow list mint is open. So we need to change it to be where only the public mint is open. So true, while allow list mint is going to be false for now. Hit transact. Hit confirm. So hopefully that's went through. Let's make sure that go through. Let's see. No, it's still pending, looks like. Once it's done pending, we can go ahead and test out the public mint. Let's go ahead and get this ready. So let's try to mint 3 NFTs because we're allowed 3 NFTs per wallet, right? So right now, I'm going to mint 3 NFTs. So ID of 0. How many? 3 per wallet, of course. And again, if I try to mint more, it actually will give me an error. I'll try to mint 3. We need to pass in how many? 0.06 Ether. Right here. Let's pass it into the value section. In Gwei, this is how much we have in Gwei, of course. And at this point, this public mint, let's go ahead and try to transact. Let's see. Look, beautiful. 0.06 Goerli ETH being sent. Hit confirm. Let's try this now. Let's make sure it all works. Let's go ahead and mint these NFTs. Man, this guys is the ultimate smart. I mean, I call it an ultimate smart contract for a reason because it really is the ultimate smart contract. There are so many things in this smart contract, guys. You know, it's insane. So there we go. 3 have been minted. Okay, beautiful. For this specific smart contract. And you'll notice that we have a balance now of 0.06 ETH. 0.06 ETH balance. Beautiful. Let's go back to our smart contract and you'll see it right here. Now, let's try and now release the fund. So let's say we made, you know, 0.06 ETH of, you know, money, right? 10% of that 0.06 should go to me, and then the other should go to the other person. Let's try it. So to do release of funds, here's what I can do, guys. Release right here. This one on the top, release. So release, basically, we're gonna release to what account? The account that we have, the one we specified was to this one, the 357, right? That was the first one. So I'm gonna try to release it to this one and hit transact. And hit confirm. Let's see what happens. I think it's done. Okay. So you'll notice here, now it says 0.054 ETH because 10% of 0.6 was exactly, I think, 0.0 something, right? Right. So 0.054 went to me. It went directly into the 357. You see, we've increased our amount here. The 848, which is the other person, right? They had 90% of shares. Let's go back to that one now. Account 2, beautiful. 840, see, notice the 0.2 right now. This should increase. So now if we try to release for the other person, copy to clipboard. Let's release for the other person here. Command V, hit transact on this one. Okay, hit confirm. Let's see, hopefully this will be done here in a little bit here. Looks like it's still going. Awesome, there we go, sweet. So release the funds as you can see, right? Let's go back to our here. Now we have a balance of 0. And let's look at our 848 one. 0.254. The rest went. So 90% went to this address. 10% went to the other address. You can see. And that's how we split up funds post mint. And that's pretty much it, guys. So what we can do actually now at this point is let's go and double check this contract on OpenSea. Okay, so there we go. Here is our smart contract. If you view it on Etherscan. This is this one right here, 0xb84 3c8. Let's go ahead and copy this. Just hit the copy button. And as the usual, go to OpenSea testnet. It's a drill now. OpenSea testnet. Click on the OpenSea testnet. Paste in the contract address. And it might show up. It might not show up. Again, I like to just hit enter. And a lot of times it will show up right here. If it does not show up, again, just give it some time, wait some time, and then it will. Click on it, and there we go. There is our Web3 Builder 0. Now, one thing to note here that's really cool. There's actually 3 items, but unique item is 1. And this is all because of the ERC 1155 smart contract. If we click on this smart contract, you will notice that 3 owned by you. And that's the whole goal of ERC 1155. You can own multiple NFTs of the same ID. They're technically, yes, unique, but you can own multiples of them. That's why you can have thousands, you know, hundreds of thousands if you wanted to. That's why here you can see list 1 item, but I can also list 2 items or 3 items, depending on how many I have. And there's your ERC lengthwise smart contract on OpenSea. Beautiful looking. That's it. Let's build the ERC 721A smart contract. Very different from ERC 721. You're gonna build the mint function with a supply limit and the requirement for payment. I'm gonna show you the difference between the ERC 721 smart contract and the ERC 721A smart contract that was built by the Azuki team. Of course, we're gonna add the withdraw function to withdraw money from the smart contract. And finally, you're going to create refund functionality as a way to give users a lot more confidence into your project. This is going to be a fun one. Let's get into it. ERC 721A smart contract, what is it? As you guys know, it's an improved implementation on the ERC 721. What really it means is that it's much more efficient than ERC 721, basically. That's the whole goal here. To get started for us, we need to go to Remix, get started from there. So all you want to do is type in Remix in Google. Let's just say here, okay, type in Remix IDE, like so. Remix IDE, and then it'll go to remixproject.org. And then depending on where it is, somewhere on your side, you can scroll to the bottom and you will find Remix IDE right here. That's right. So click on that and you will be presented with a view like this. Now, all is great. Now what you want to do is you see this little plus icon right here. You just want to hit a plus icon and create a workspace, or you probably have a default workspace right now. And now what you want to do is add the contract in the contract section. You want to do right click on it, hit new file, and then call it ERC 721A with refund. There we go, the SOL. So that's going to be your smart contract that we are building today. The next step, we need to go ahead and actually create our smart contract using an Open Zeppelin wizard. So let's go ahead and do that. Everybody now go into Google and type in Open Zeppelin wizard. Boom, done. Okay, Open Zeppelin wizard, and on the wizard you will have a few options. You have the ERC 721, ERC length defined, and we only need the main one, which is ERC 721. Okay, and here it is, right? You've got your token and so forth. So name it, right? Let's go and name our contract. Could be anything you want it to be, whatever your heart desires. Okay, it can be the best thing in the world, Web3 builders. It could be doesn't matter, honestly. All right, so I just want to name it. I'm going to call it Web3 Builders. Boom, that's going to be my contract. That's going to be my project. I'm going to call it Web3, WE3. I think it's just a symbol. A symbol is like a token for, think of it as like a shorthand for your contract name or for your smart contract or for your NFT. Base URI, I have that down in the description, guys, so make sure you follow down below to do that, right? And the IPFS I have for you guys is right here. Let me go and copy that. You should see it in the description of the video. Here is my IPFS. I've already uploaded the JSON data for you, so you don't have to worry about that, okay? Then just hit Mintable. And that's pretty much it so far, okay? I don't need anything else on top of that because we're going to change a lot of things in any case. Now you want to copy all of this. Copy. This copy to clipboard never works for me, so I just copy like that pretty much. Okay, and then you want to go back into Remix right here, I believe. Yes, right there. Beautiful. I'm going to go back to Remix. So here's our contract that we've created before. And now, boom, paste it in. Say, okay, you know, for, on the warning sign, don't worry about that. Not the most important thing that we need right here, okay? A lot of things that we're going to change. So as you know, this is the ERC 721 smart contract, not the ERC 721A. That's right. So what we want to do now is transform this into the ERC 721A. Got it? Let's go to ERC 721A right here. So I have this ERC 721A.org where you can go to GitHub and actually find it. Boom, boom. Oh, great. You can read through it. You can read through the contract section, but we are actually not using this one. That's right. We're not using that one. We're not. Right? We are instead going to be using a one from something called ERC 721R. That one is where it includes the refund functionality. So all you want to do is go to Google and just type in ERC 721R right there. 21R 21 right there. So there you go. And you should see this right here. Exo Digital Labs, ERC721R, Refund, and so forth. So click on that. And you know, you can read through this as well, but the main thing you need to understand is go to the contract section and you have a custom ERC721A contract. So there it is right here. Okay. And this is exactly what we need to import basically into our smart contract. Okay. All you got to do is you see this link on the top right there. Awesome. All you got to do is just copy that link, hit Command C, go back to your remix and then import that. Remove this ERC721 and import that one. Oops, you just gotta go like this. You gotta go import and then put this instead right here. Boom, and save it. Now it's gonna give you an error, which is completely fine. You need to change this ERC721 to ERC721A section and hit save on that one. And then of course right here, when you create the constructor, you need to change that to ERC721A as well. Everything else stays the same for now. Save that. Next thing, we need to import now the ERC721R section, which is for being able to refund our NFTs. All we gotta do now is go back to our Exo Digital Labs ERC721R, and you will notice a few things here. So it looks like we are importing ERC721. Beautiful. We will need to import now this ERC721R, right? And this is an interface. So basically it tells us, hey, we can actually use this functionalities. It's an interface basically. So I'm going to copy this one, Command C, same thing, go back to my remix. And then we want to import, there it is, ERC721R. Okay, that's it. And then make sure you add a semicolon. Without semicolon, you have nothing, guys. Very important. So now we've got that part. Let's go ahead and talk about the differences between ERC721A and ERC721. And what I got for you is pretty much something, a really cool presentation right here. And I want to touch on that. So as you guys know, we have ERC721 where a person owns what? An NFT. Correct. So one person owns one NFT, like for example, like in this case, this is the Bored Ape, right? Beautiful. In terms of how we save that data in a smart contract, you'll notice here's the contract example. You'll notice that it's all saved inside a mapping where a token ID is mapped directly to an address right here. So you have token ID of 0 mapped to your address, hence why we know who's the owner of your specific NFT right here. So all is good said and done, right? And of course, when you think about how that data is saved, we have, this is a box for, think of it as like a box in memory. For every single NFT, we save your address in that box. Boom, boom. And even if you have, let's just say you have both the 0 and the 1, right? You have both NFTs, you bought 2 of them, then doesn't matter. At the end of the day, you're still gonna be saved in both boxes, like so. And of course, if you buy another one, another person buys another one, it'll be saved right here and so forth. The difference here within Azuki with ERC721A that was built by Azuki itself, right, is the following. So if you look at this one, right, you'll notice here that, you know, it's still, again, we're mapping an integer to an integer. And the one really cool thing here is that it's about how we're saving that data, guys. Before we were saving the data like to 0 to an address. So now whenever we have a duplicate address, let's just say, as in you both bought 0 and the 1 token ID is not going to be set at all for the address. That's right. But then for new people, it is going to be. So here's what I mean by that. Okay. If you bought 2 NFTs, 0 and 1, it will set initially your first NFT that you've bought, it will set your address, but then it will not set the address the next one, because we know that in order for you to find who's the owner of this one, we have to go back to here, and this will give us the owner of one. And so that's where that saving of data comes into play, and that's also pretty important, you know. Now moving forward here, and that's how we save the data in ERC721A, hence why we get gas savings like this. And you'll notice here, right? If Alice is the owner of 100, she's also the owner of this one and of this one. But of course, you'll see that there's no owner set on these ones. Same thing with the Bob. Bought 2 NFTs, 103 and 104, but there's no owner set on this one as well. See? And so that's where that data is saved. It's not the only thing that differentiates ERC721A from ERC721, but it's one of the main things, okay? Hope you guys understand that, all right? What we want to do now is we want to be able to change this main functionality, right? So the first thing you want to do is change this main functionality to include the quantity and remove this owner. Because if it's only the owner can actually mint, then there's no use for this at all. So let's go to remove this public only owner. Okay, we don't need that. And instead of a safe mint address token ID, we're going to say this. We're going to say, hey, you can actually mint a few NFTs. You went 256, give it a quantity. So quantity, beautiful. And when we actually do the safe mint, mint, it's going to be to the message.sender, because again, this is message.sender is coming from an object called message, which is coming directly from MetaMask. MetaMask fills this in for us. And then token ID is going to be a token ID that we will fill it in here in a second. But instead of token ID, it's actually going to be quantity, right? So ERC721K keeps track of which token ID you're going to mint, because you're minting from 0 to 1,000 and so on. Let's go ahead and keep going with this, because at this point we're in a pretty good state, right? We've got our quantity, we're minting this, and we can mint our NFTs now at this point. Of course, this is not the end, okay? Now we want to be able to add payment. That's step 2, right? So let's go ahead and add the payment functionality. And to add the payment functionality, you need to mark the function payable, okay? Very important, payable. So let's go and mark the function payable, because that's how we can accept payments. Payable, and let's go and create on the top, create the cost of this of individual NFT. So we're just going to create a constant. In our case, it's going to be uint 256, like so, public. Okay, constant, so meaning it's not going to change. And then we're going to say mint price is equal to, right now it's going to be 1 ether. Very important, guys, right? Ether, not ETH. Okay, so we want to go ahead and save that now. That's going to be our mint price. And in order for us to actually understand, to actually require that payment, we have to do require statements. So we say require, you say message.value should be what? Should be greater than or equal to, what is it? Mint price? No, it's not just that, because if you're trying to buy 2, let's just say the mint price is 1, right? If you're trying to buy 2, technically you have to pass in how much money? You have to pass in 2 NFTs, correct? Pass in 2 ether, I'm sorry. So we need to multiply mint price multiplied by quantity. So basically, if we buy 2 NFTs, we need to pass in 2 ether. Otherwise, if you did not pass that in, then of course you say not enough funds. Oops, not enough. Enough funds. Awesome. And so now this will require for us to actually pay to mint 1 NFT. Got it? Now, next up, we need to go ahead and limit how much a person can mint. Right? So a lot of times a person can mint 2 or 3 or 4, and we want to limit that number. All right. So let's go ahead and make that happen right now. There's actually a really cool functionality that ERC721A has that ERC721 did not. And that's something called number minted per number minted. So all I got to do is go to require here, require. Okay. And there's a function called number minted. If we go to ERC72121A, let me show it to you right here. There's a function inside here. It's called number minted. You see the total amount of tokens minted in the that's total minted. Where is it? No, oh, there we go. The number of tokens minted by owner. Okay, which is what we want exactly. It's something that ERC721 did not have initially, right? And this is returns us just how much an owner has minted. So all we have to do, if we go back to our remix, say, hey, the number minted by the message.sender, right? Plus whatever quantity he's trying to mint right now should be less than what? Should be less than or equal to what? Some number, right? The max minted per user, max mint per user. So let's go and create that constant here. So we say uint 256 public constant max mint per user, like so. Well, let's just give them 5, right? So a person can only mint 5 NFTs in general. And so it has to be less than or equal to whatever the max mint per user is. Or come on. User. I thought it would give me like some suggestions, but it does not. So now if you're trying to mint, let's just say 5, we're trying to mint 5. It's going to say, okay, number minted so far is 0, because right here plus 5, okay, is still 5. But if you're trying to mint 6, let's just say, then it's not going to be good. And hence why if you're trying to mint 6, it's going to be, 0 plus 6 and, plus 6. And that's more than max mint. And hence it's going to give you an error. And so we want to specify an error here. And this error would be like, mint limit. Okay, beautiful. Sweet. So we have required that. Okay. Let's go ahead now also require the total supply. Meaning if there's 10,000 NFTs right now, right? Well, we want to make sure that people cannot mint in general more than 10,000 or more than 1,000, whatever that number is. So to do that, we need to do require. And inside here, we say, okay, there's a function called total minted. If you go back to our ERC721A, that's already built for us. Yes, there's a total supply function that works as well, but there's also total minted. Where is it? Total minted right there. Total amount of tokens minted in the contract. Okay, that's it. So a very useful functionality for us. So let's go back to our function. So we say here underscore total minted has to be what? Has to be less than or equal to, let's create a max supply. So right here we can create uint 256 public, right? No, not public constant max mint supply. And let's just give it maybe 100 for now. It could be 1,000, could be 10,000, whatever your heart desires. Okay, very important. We should be less than or equal to what? Max mint supply. Okay, otherwise we say, for example, supply exceeded, or we just say sold out. That's the error message pretty much. Now, very important here is that we need to account for the quantity as well, because if we say just simply total minted, then you might have minted 0, let's just say, right? But now you're trying to mint, let's just say 10,000, okay, let's just say, or 100. Well, it's still gonna mint it for you, so you have to actually add the quantity inside here to accommodate for that. Beautiful. Let's go ahead and semicolon. So that's kind of that. So we've max mint, I misspelled that, max mint supply. There we go. So we've got that. Okay, we can now mint, as many NFTs as we want, not as many, but there's a certain limit per user. There's a limit in general for the whole contract. And then of course it requires payment. So, which is really cool. Now, moving forward here, let's go ahead and create a withdrawal function. So we need to be able to withdraw funds from here, because of course, as you know, whenever you make or you pay, towards the smart contract, where does the money go? The money goes directly into the actual contract. It becomes an escrow account. And so you have to withdraw it you have to withdraw that money pretty much to accommodate for that. Okay, this is very important, by the way. A lot of people have actually, there's a smart contract that have like millions of dollars in them because people forgot to create a withdrawal function. It's pretty insane. So let's go ahead and create that. Let's go ahead and make the withdrawal function. So all it is I'm going to say here function withdraw, and then we don't need to specify to who we're withdrawing to. We say external, and then only owner. So only the owner can actually withdraw this function. Okay, very important. Okay, guys, withdraw only owner. Okay, so to do that now, what we gotta do is we have to say here uint. So we'll get the current balance of the contract. So uint 256, like so, 256, and we say here balance. And to get the balance, all we have to do is we say address this dot balance. So how much money does the current contract have? And that's what gives us that ability, guys. Got it? Beautiful. Now, since we have the balance, we have to what? We have to pay to that balance. So we say address dot send value, and here we say payable. We make the payable who? The owner. So whoever's the owner of this smart contract, or it could be the message.sender, right? So it's probably message.sender, for example, message.sender, right? Comma, and we're gonna send them the what? The balance. And so now we're going to send this value to the message that sender or the owner of the smart contract, because of course you can see only the owner can actually do this. Okay, makes sense. So now let's go ahead and test this out, guys. Very, very simple. To test this out, all you got to do is now go to your deployment. This is your compile section, right? This is of course your compiling section. And if you go to advanced configurations, you want to do enable optimization to 200. This is just to make sure that your files are a bit smaller in size and hence decreasing your gas fees. Okay, pretty important too. If you go back to our deployment script right here, you want to go ahead and deploy, right? So make sure you select the correct contract. I think in this case, what did I name it? ERC 720Y1A with refund. So let's make sure I have the correct one. That's exactly which one. Hit deploy. It's going to deploy. You're not using, Goerli testnet or anything like that. And you should see it right here on the bottom. And these are all the functions you have available because of what? Because of ERC 721A functionality. That gives you a lot of the base functionalities. From here, we need to test out minting NFTs. So let's try to mint 2 NFTs. And if we transact, you actually notice that there is a not enough funds section, meaning you have not passed in any money whatsoever. And so that's bad. It's like, yo, give me the money. Okay? Give me the money. So to pass in money with Remix, all we gotta do is pass it in right here, this value section. Okay? And if we're trying to mint 2, how many ether do we need? We need exactly 2 ether. Exactly. 2 ether, right? So I'm gonna pass in here, go into way. I'm gonna select ether here. I'm gonna hit backspace and just say 2 ether like this. And make sure you click out of it to make sure that it saves that amount. And now if I hit transact, boom, it transacted. And now I am the owner of those NFTs. And so you'll actually see that in terms of the balance of, if I do a balance of, let's just say of my wallet address, I use the balance of function to figure out if I'm the owner, it will say that I own 2 NFTs, which is beautiful. And then if we go to token URL as well, if you go to like, for example, 0, you get your IPFS link with the 0 NFTs, the 0 token URL, right? So pretty cool. So we've done the base functionality, guys, which is amazing. Moving forward here, we want to now add a refund. Now we want to be able to refund people, okay? So let's just say, you know, this is something that a lot of people, I feel like, are going to start using in the upcoming NFT projects, which is to be able to refund NFTs, or for people to be able to refund themselves. If you want to look at it here, there's a lot of examples that are specified inside this contract, inside ERC721R. If you look at the ERC721R example, you will see a lot of, you know, things like, for example, the refund address, the refund and block number, right? The refund period and so forth. And so this kind of gives you some knowledge of what you actually need. So the first thing we are going to do is, you know, every person should be able to refund themselves if they don't like where the project is going within a certain amount of refund period. So let's go ahead and make that happen. So the refund period in this case is kind of like this, but we're going to make this a little bit different for the refund. We're not going to use the block number. I'm not a big fan of that. So instead, we're going to create this. Check this out. We're going to say here, uint256, public constant, okay, again, doesn't change. I'm gonna say refund period. There we go, period. Is equal to, pretty interesting actually, it's gonna be equal to 2 minutes. In your case, it might be like 45 days or 30 days. And actually that when you say days, that gets converted timestamp, which is really cool, which is something I didn't even know, you know, for a while basically, but you can use that. So I'm here for testing purposes. I'm going to say, let's just say 3 minutes, okay? Boom. For now. So what does that mean? That means that people can refund their NFTs within 3 minutes, right? So that's going to be our refund period, okay? Now, we have our refund period. Now we want to go ahead and add a mapping, because whenever people refund, we need to say, hey, if you minted, let's just say tomorrow, you should still have 3 minutes to refund. So we need to create a mapping that stores when your refund timestamp is. Very important here. So I'm going to create a mapping here. It's going to be a mapping like so. It's going to go from a uint256 from a token ID down to, and also uint256. And that's going to be a public mapping. That's going to be a refund and timestamp like so. Right there, refund and timestamp. So this is going to be a mapping for the refund and timestamp. Okay. And then we're going to create another uint, a 256, and this is going to be public as well. And this one is to know, okay, when is that end of the timestamp? When is that end? So refund and timestamp. And I know it's the same variable as this, but we're gonna call this timestamps, because this is a timestamps per user. So token ID of 0 has this refund timestamp. Token ID of 1 has another refund timestamp. So different timestamps per specific NFT. Okay. So there we go. Refund and timestamp. Amazing. So we've got that. And then finally, we want to track who has refunded. So we're going to say create mapping here between uint56, which is a token ID, to what? To a Boolean, if that person has refunded or not. So bool, and we're just going to give this a public as well, and then has refunded. Again, keeping track of who has refunded before. So we know that way people don't refund twice or 3 times or 4 times, right? We don't want that to happen. That doesn't make sense. Okay. So awesome. I love that. The next thing we need to do now is figure out refund address. It's like, where is the refund address going to be used for? So when a person refunds the NFT, when a person refunds the NFT, right? The NFT gets removed from their ownership, and then it goes back to the owner of the actual contract. That's right. It goes back to the owner of the contract. That way you can sell it later on down the line, let's just say. But that's what we want to do for now. So a refund address is going to be an address that gets refunded right here. So I'm going to create a address here, address public, and I'm going to call this refund address. And I'm going to set this to nothing for now, right? Okay, but that's completely okay. And then inside here, I'm going to say address or refund address is equal to address of this, like so. So it's going to be the address of the current contract. Okay, beautiful. And then let's figure out what the refund timestamp and timestamp is. And of course, right now, the refund timestamp is what? Is equal to, so what is, if we give it like 3 minutes, we need to take the current timestamp and do what to it? We need to get the current timestamp and then add the refund timestamp. Got it? So let's go ahead and do block.timestamp plus refund period, like so. Refund. And so we'll actually correctly calculate how much that is. So if it's 3 minutes, it's gonna add 3 minutes to the end timestamp. I'm gonna shift some things around because I'm a big fan of putting things together. So let's just say here, this is correlated to the mint, the NFT mint. So I'm gonna separate these, and then I'm going to put the refund stuff as well together, like so. So this actually creates your contract a little bit more cleanliness as well. So I'm a big fan of that. And then actually makes it more gas friendly, because if you put mappings around the mappings, UN256 to 126, the compiler can be a little bit more efficient in terms of how it saves that data. Now we need to save the data in terms of we need to figure out what the refund timestamp is per person whenever you mint the NFT. So let's go ahead and do that. Let's figure out your current refund end timestamp, because you might be minting today, you might be minting tomorrow, it might be minting the next day. So our goal is to figure that out. So we say refund and, why is it not giving me suggestions? Refund and timestamp right here is equal to what? Refund and timestamp is equal to the current block timestamp, block.timestamp, plus the refund period. So that's going to be our refund and timestamp. We need to save that where? We need to save that in the refund and timestamp section so we know per token ID. Now, how does that happen? Well, we need to create a loop. And I know it's not the most efficient thing to do right now, but for now, we'll just make that happen. So we're going to say create a loop for, we're going to say here, uint 256, okay, right, is equal to, this is very, very important, guys. Equal to what? Because remember, we need to save. So if you buy token ID of 22 or 23, your token ID of 22 needs to have a certain timestamp. And so how do we know the specific token ID? Well, it's something by using something called current index. If we look at our actual ERC 721A example, like right here, you will notice there's a current index right here. The token ID of the next token to be minted. Okay, so if you minted, let's just say 3, you can have 0, 1, right? So if you, let's just say here, let's think about it here. If you minted 3, here's our, like so, 0, If you minted 3, then you technically you have this NFT, 0, 1, and 2. And the next token to be minted is going to be which one? This one. And so that is currently our current index right here. Current index. And what we need to do now is we need to save the refund timestamp for these ones. This one, and this one. So that means what do we need to do? We need to subtract them. That means our I does not start from here from the current index, but our I starts from the current index minus what? The quantity. So it's 3 minus 3, it's going to be 0. So we say here, underscore current index minus what? The quantity. So we're going to start from that number pretty much, okay? And then now we need to make sure that the I is less than the current index, right? And of course, we're going to do I++. So let's go ahead now and save the refund period. So we'll say refund, what is it? Refund and timestamps. Beautiful. And it's timestamp at the position of I is equal to what? Is equal to the refund timestamp, like so, I believe. Timestamp. There you go. Awesome. Refund timestamp. Refund and timestamp, sorry. Refund and timestamp. So now we're saving the refund and timestamp for every single person who's actually minting the NFT, which is amazing, right? So if it's 2 minutes ahead, we know that you can refund in the 2 minutes ahead. But of course, we're not done yet, guys. So we have saved the data for the refund, for the refunders, okay? Now you minted your NFT, you have 10 days to refund. You know, another person mints their NFT, they have 10 days to refund as well, but from the time that they minted. Let's create the refund actual function. Let's create the refund function. I will say here function refund. And just so you know, for those of you who are interested, where you can actually really understand this is if you go to ERC 721R, which is for the refunders, okay? Go to there. If you just scroll through and you want to look through it, you will actually notice a lot of examples that you can use. So if you go to contracts here, you get this example. You can learn a lot from just looking at this in terms of how they actually refund, right? So we're going to do the same similar situation in terms of what they're currently doing, but I modified it a little bit because I think it's a little bit better in terms of how I modified it. Now, let's go back to our remix here. So far pretty cool. I'm actually pretty pumped. Function refund, function refund, and we need to specify for the refund. I'm just kind of thinking here, the token ID you want to refund. So let's go ahead and say uint 256 token ID. So I want to refund my 0 token or 1 token, whatever it might be. And of course, there's going to be an external function, and that's it. So we've got a refund function. Now, a few things. We need to make sure you have to be the owner of the NFT, the owner of the NFT, guys, right? So when you say we require that what? Message.sender is equal to the owner of, and so there's a function called owner of this token ID. Otherwise, like if you're trying to refund, you know, an NFT that's not yours, that's not right. We should not be able to do that. Let's go ahead, and if that's not the case, it's just gonna say not your NFT. Moving forward here, we need to figure out what is your refund amount. How much are you supposed to be refunded? What we're going to do is we're gonna create another function, and let's call this function get refund amount. And again, we're gonna specify the specific token ID. So we're gonna say, hey, UN 256, and then we'll say token ID. Boom, awesome. And then public, of course, view returns. And it's gonna return a number. Also, UN 256, 56. There we go. Get refund amount to figure out how much you're actually going to return. And to do this, what we do is return the mint price. For now, going to return what? The mint price. But we only want to do that, right? If you have not returned yet. So if has returned of this token ID, if you already returned this token ID, if you already returned this amount, then you just say return 0, right? So if you already have returned it, let me see, let me keep track of this. Has returned. Oh, it's called has refunded. Sorry, it's called refunded. There we go. Has refunded. Okay, beautiful. So if you already have refunded, then of course you return 0, okay? Otherwise, we just return the mint price, okay? Pretty simple here. Now, so here, what we need to do UN 256 refund amount is equal to get refund amount of the token ID, okay? This is gonna tell us how much, you were actually going to refund to you. Okay, very, very important. So we've got the refund amount, we've got that. Now, of course, when you go ahead and you mint, we also want to make sure that you have not had the deadline. Meaning, if you're trying to mint after the deadline, then of course you should not be able to mint at all. Let's go ahead and figure out that deadline. Okay, let's go ahead and create a function here. Function get refund deadline as well of the UN 256. 50C of the token ID. Also going to be public view, and it's going to returns also UN 256 because it's going to return a timestamp. Now to figure that out, we want to make sure, okay, also as well, if you have refunded or not. So if you're refunded, then just, deadline is 0. You should not be able to refund at all. Otherwise, we return. We have to go back to where we say the timestamps, right? This refund timestamps. And we specify the token ID for that one. There we go. Otherwise, we get the refund timestamp of that. Okay. So get refund deadline. And so now what we need to do, guys, right, is we need to make sure that when you're minting your NFT, your current time is less than what? Is less than the refund time, right? So if think about you go to a store and you want to refund a product, okay? What do you want to do? You want to refund the product. You cannot refund the product past 30 days. It has to be less than whatever that refund period is, okay? Let's go back to here. And basically, all we want to do is just hit require. And we want to say that the current timestamp, block.timestamp, so that's something that's available to us, block.timestamp should be less than, right, than the get what? Then the get refund deadline. So refund deadline, of course, just passing the token ID here. Otherwise, then refund period expired. There we go. Beautiful. So, okay. So we're getting this. Okay, great. All is good. So we're trying to refund now. We've got the refund amount. And then now a few things we need to do. First thing is we need to transfer the ownership, transfer ownership of NFT, and then of course refund the price, and then of course mark refunded. So first thing is we're gonna transfer the ownership of the NFT, right? So all we want to do now is undo _transfer. There's a transfer function that's given to us by ERC 721A, a transfer function, and it has a few inputs. You notice here, if you go back to our ERC 721A, it says right here. If you go to _transfer from the to and the token ID. It's as simple as that, right? From to the token ID. So let's go back to Remix. We're transferring from what? From you. Transferring from you, the message.sender. So we say message.sender to who? To the address of the refund address. That's right. The refund address, which is just address this. So refund address. So let's go ahead and refund, where is it? To the refund address. And then we want to transfer this token ID. Transfer ownership of this NFT and so forth. Once we've transferred it now, it's time to give you the refund. But let's go ahead and mark this first. So it's going to give you the refund. And same way, in the way we transferred money before, we're going to transfer money now as well. So here we're going to say this address.send value, and it's going to be to what and how much. So we want to specify message.sender, comma, how much? The refund amount. We're going to specify, sorry, I meant to say I have to specify that it's payable as well. So we need to make this payable, and then we're going to specify the refund amount. Send value, payable, message.sender, and then the refund amount. And once we have refunded to you, we want to what? We want to actually mark that you refunded. So it has refunded of token specific, the token ID is equal to true. Now, very important that we need to do though, this is a little bit unsafe because this can cause for a reentrancy attack. So if this function gets called multiple times, you can potentially have the ability where you just send yourself the value, many times. So prevent that, we need to put this above actually this. It's literally one line of change, because if you try to call this function, well, this gets set first and then we set the value, right? And so hence now that's going to be a problem, because if you try to do it again, then it will just never get to this, right? This is called a reentrancy attack, which is really very interesting, guys, which we can talk about later on. But that's pretty much it. So we set this to be true, we send the value, we transfer the ownership, and that's your refund function. Now, we're not done yet, because the withdrawal function needs to have accommodated for this too. We cannot withdraw past the refund period as well, right? There's no point of people to refund the amount or to withdraw the amount if the refund period has not passed. In 30 days, that money is locked in this escrow account, and it's like, hey, you cannot take that money unless, it's past the 30 days mark. So let's go ahead and do that. So the withdrawal function needs to be, we need to require that the current timestamp, the current block.timestamp, timestamp should be greater than what? Greater than the refund, the refund end timestamp. So we need to be past this. And then if not, it's not past the refund period. Okay, that is it, my friends. So we check for that. If that's the case, then you can actually withdraw the money, and boom, you're done, right? You're all good, right? So what this does is this basically makes the project actually deliver, right? This prevents from scammers. And so people who will be a lot more comfortable in putting money into an NFT that has a refund. It has a refund potential. So there's pretty much that, okay? Now moving forward here, and we need to just test it now. Let's go ahead and test this out and see how this is working. So again, let's look into our deployment right here. Let's click on our deployment, click on deploy, close out all the other deployments, because sometimes when you have too much, it's like you cannot keep track of it. So I'm gonna hit and select the new one and hit deploy. Okay, awesome, sweet. So now let's go ahead and actually mint an NFT, and we have 3 minutes to completely refund. 3 minutes to completely refund. And so let's go ahead and try that right now. So I'm going to mint, let's just say 2 or 3, 4 NFTs. Let's actually mint 6. If we should get a error if we try to mint 6. Let's see. If I try to mint 6, and if I try to pass in 6 ether, doesn't matter because it should give an error as well. There we go. See, mint limit, right? So you cannot mint past, you can only mint under, maximum is 5. So let's mint that maximum 5 and pass in 6 ether instead. Let's go and transact. There we go. So, and you can actually check the total supply here. It looks like it's 5, the total supply. And then here's token URI. So if you could close that, there's our token URI, which is beautiful. That's amazing. And that's it. And now let's figure out the refund period. This is the refund period, which is 180 seconds, because we're saying 3 minutes. Okay. And then let's figure out the refund and timestamps for every single NFT. If you go to 0, for example, this is the refund timestamp for that one. You see what I mean? So we know the refund timestamp for every single one. If we try to refund, it will actually work. So let's go ahead and try to refund. And you notice here, this thing right here has 6 ETH right now, right? Has 6 ETH. Okay, great. So it has 6 ETH. And now what? Now we want to go ahead and refund for the mint price. So let's try if we want to refund 1 NFT, let's just say. you should notice that this 6 ETH becomes 5 ETH, and we should notice more money inside our account right here. So just keep track of that, guys, okay? Let's try to refund 0. If you hit transact, boom, has refunded. Look at this. This went down to 5 ETH, and then this went up to 94. Now, if we wait 3 minutes, then we should not be able to refund. But like, for example, you notice here, if I try to withdraw, it will not let me withdraw because, right, it's not past the refund period yet. So 3 minutes has not passed since I minted to be able to refund the money, or to withdraw the money, I meant to say. So we have to wait 3 minutes, which is unfortunate.
2 hours later.
So if I can withdraw, then I should not be able to refund. Let's try to refund again a specific token ID. Let's say 2. A refund period has expired. And it's exactly because we've passed the 3 minutes mark. That's why the refund period has expired. Okay? And that's pretty much it, honestly. So this was your ERC 721, a smart contract, okay, with the refund functionality. You know, this is really, really clean, really well done. And of course, there's more to it you can do once you actually get set up. Hope you enjoyed that video. If you got any questions, leave them down in the comments below. Other than that, don't forget to hit that big like button. Let's move on to the next one. In this video, we will build our own CryptoCoin on an Ethereum-made network. We will write our own ERC20 smart contract using Solidity and OpenZeppelin. Then we will deploy your token to the Ethereum test network using MetaMask and Hardhat. And finally, we will allow users to buy and sell your own crypto token. How cool is that? All right, so for part 1, we are going to be installing Hardhat, and then we'll be creating our initial project repository using Hardhat, okay? So go into your terminal, as you can see right here. From there, go into a folder where you want to create your project. So in my case, I will do cd project right here. And inside this, I will go ahead and make a directory using something called McDeer, and I will create a project for my CryptoCoin. So in my case, I'll call it Web3 Builders Coin, whatever it might be, right? Web3 Builders Coin. That's my coin. Go ahead and hit enter. Beautiful. All right, once we've created the folder, we need to go into the folder. So we'll do cd Web3 Builders right here, Web3 Builders Coin, hit enter. That will go into the folder. And let's go ahead and initialize our project using npm. So npm init, initialize our project, call our project, give it a name. So Web3 Builders dash coin. Make sure to add a dash in there. Boom, hit enter, 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 and hit yes. And that's it, guys, okay? Once we've got that, what you want to do is now do npm install Hardhat. So let's go ahead and do that. npm install -- save dev Hardhat, just like that. Hit enter. There we go. So it's going to install Hardhat. Those of you who don't know, Hardhat is amazing for basically initializing smart contracts. Okay, give it some time. Now all is good. To initialize our project, we need to do npx Hardhat like this. npx Hardhat, like so. Boom, hit enter. Create a basic simple project, hit enter on that one. And here's your root. So Hardhat project root, as you can see right there. That's going to be my root. So I hit enter. So make sure you have the Web3 Builders Coin right here, or whatever the name is pretty much. Let's go ahead and say yes for that one. Do you want to install the simple dependencies with npm? Yes. We're done with that. Okay, next up, we want to open up our project in VS Code. So let's go ahead and do that right now. So make sure you do VS Code, a new window in VS Code. If you don't have a new window, I'm going to just put it on the right side like this. Hit open up your project like so, Web3 Coin. So I went to the projects folder, Web3 Builders Coin, hit open. Okay, there we go. Yes, I trust these authors, and then all is good. And so now, my friends, we have ourselves contract. Look at that. We have our initial contract called Greer.sol. And that's pretty much it. For part 2, let's create our ERC20 token using OpenZeppelin. We are going to use OpenZeppelin starting wizard. So let's go ahead and do OpenZeppelin, Zeppelin wizard. Just type this out. And this wizard will allow us to create our initial smart contract, okay? So you can see, we're going to select the ERC20 smart contract right here, right there. Give it a name. So in my case, the name is going to be Web Builders, Web3 Builders, right? So symbol. W3, all right, and then pre-mint is how many do you want to pre-mint initially for yourself. So I'm going to give this a 10,000 supply. There we go, that's supply. And Intersupply, remember, we have all these decimals right here. If we zoom in on this right here, the reason why it multiplies it by 10 and then decimals is because of the fact that, remember, from the 10,000 coins, we can also have, you know, fractions of a coin. I think it's like 18 fractions of a coin that you can have. So that's how we always add so many decimals to the 10,000. Then what you want to do at this point is just copy this whole thing, this Pragma Solidity thing, just copy that. Go to back to VS Code, and then let's create a new contract here, okay? So right click on a new contract, hit new file, and inside that type in web3 builders coin.sol. So Solidity, of course. And then Command V on this one. And then just hit save. Now, as you can see, we don't currently have OpenZeppelin installed in our hard hat. So we need to install that first. Let's go ahead and right click, open an integrated terminal, and then from there, I'm going to do cd // to go back to the root folder, because currently I'm in the contracts folder, and I don't need that. I want to be in the root folder of the Web3 Builders coin, and just do npm install OpenZeppelin contract, and that is it, my friends. Boom, boom, like this. Let that install, and once we install that, we should see this red completely removed. Okay, 1 second, there we go. Now, the only way for us to see this is let's go and open this one more time. You can see right here, now we see OpenZeppelin. And that's it, my friends. You've created your ERC20 token, but of course, that's not it. Next up, we need to now deploy your ERC20 token to the Ethereum testnet. Now you set up the config to be able to deploy your CryptoCoin smart contract. And how do you do that? Well, it's pretty simple. In hard hat, if you just simply go into hard hat and you type in hard hat config, you can see configuration, Ethereum development environment. And if you scroll down, you will actually be able to see everything you need to see. The only thing that we pretty much need to do is simply like this. We don't need anything else besides just default networks and then network. So just copy this default network. I'm going to copy that right now, paste that in, and there we go. Now, as you can see, this is using a test network called Sepolia. We're going to be using something called Goerli. So what we need to do is find an RPC node for Goerli. So we need to say here, Goerli RPC node. RPC.info right here. If we click on RPC.info, and if we do Command F and just say Goerli, there we go. There's your Goerli testnet. We can simply just copy this whole link. So copy this link to address. So copy link address. And again, this is inside RPC.info. Paste that in. There we go, Command V. So that's going to be our Goerli RPC node. And then we need to change this default network to be Goerli. Goerli. And then change this to also be Goerli as well. Goerli, right here. And now you've set up your configuration to deploy, but you're not done yet because we need to now use the private key for your wallet. Because why? You need to actually be able to spend money, right? So we need to get the private key from your wallet so that it can spend that money. And how do we do that? Well, pretty simple, actually. If you go to MetaMask, I have an account called testing right here. And the only thing that you have to do is simply export the private key from it. So click on these three dots, click on the account details, and just hit export private key. And of course, make sure you are on the Goerli test network. Very important, you guys, okay? So account details, export private key. Let's go ahead and do this. Type in your password. There we go. So I'm going to copy my private key and then save it in this variable right here, private key. Just save in this variable. And now instead in this account section, just go ahead and set the private key inside here. Just you set the private key variable right here. Now it is time to launch the coin. We need to go ahead and edit this deploy script that will basically deploy our contract, right? So in here, what do we see? In here, we see that it's getting our contract. Of course, this is the wrong contract, and then it's deploying it, and then it shows us the deployed address pretty much. Now, we need to change this to instead of being greeter, to actually say whatever this is. So this is the contract name. So you want to copy this contract name, Web3 Builder, go into the sample script, right? You can probably just change it from a sample script to just hit enter, say script.js. We don't need that to be sample script. There we go. Okay. And then inside here, just say get contract factory, use the Web3 Builder one, Web3 Builder, beautiful. And then from there, so let's go do Web3 Builder like so. Command C, this one, Command V, this one. This one's the smaller version, the lowercase version of this, right? So Web3 builder like so. Command C this, Command Command V. It's like I said, it's all about copy and pasting, you guys. Command V, and there we go, right? So it's gonna deploy our contract right here. It's gonna wait for it to be deployed. Remove this space in here, don't need that. And then once it's deployed, we're gonna get the address of the deployed contract. So like I said, open up your terminal. So open an integrated terminal, make sure you got that. As you can see, we've got our script.js, which is right here. Going to change the script.deploy to be CryptoCoin deployed. We got the Web3 builder, amazing. All right, we need to provide basically the MIT license for this contract. And all an MIT license is basically it tells us that, you know what, this contract can be used pretty much by anybody. And that's it. Now my friends, we are ready to deploy our smart contract. Let's do it. To deploy, again, hard hat. Let's type in hard hat deploy here. So I want to show you how this is done. Deploy your contracts. You can see here, right here, npx hard hat run -- network. You specify the network and then you specify deploy. So in our case, let's go ahead and do this. So now we want to run the function npx hard hat run. So we say npx hard hat run, select the network, which is going to be Goerli. And then we want to run a deploy script. Now, if you notice, our deploy script is where? It's inside the scripts folder. And then we have a script.js, right? So all we have to do is say Goerli. We say script/script.js. Let it deploy and let's see what happens, my friends. I am excited. I'm excited. Hey, there we go. We have deployed it. Now let's go and check it out on Goerli. So we want to type in Goerli scan, right? Goerli ether scan, Goerli scan, whatever you want to call it. Paste in this contract address. This is the contract address that we got right here. Paste the contract address. And now there we go. We have our coin. Okay, this is the contract for our coin pretty much. As you can see, it says ERC20 token, which is exactly what we're looking for. Now what we can do, which is really cool, you can actually see your coin in your wallet. Copy this address, open up your MetaMask wallet, and watch the magic happen. You see this assets section? Import tokens, click on the import tokens right here. Click on this import token section, type in the contract address, and boom, you can see that it has the W3 symbol. That's right, that's the symbol that you use to create your contract address. So though, hit add custom token, it says you have what? 10,000 tokens, hit import token, and now it's inside your wallet. How cool is that, right? So of course I have Goerli ETH, I have W3 tokens. What now? So how do we spend that money? How do we go ahead and spend the money, or how do we have people buy this Web3 token? This is by something called liquidity pools. So let's say you have your W3 token. So just think about Robinhood, let's just say, or just think about stock trading, right? There is a buyer and then there's a seller. So there's someone who wants to buy, then someone who wants to sell. And then the seller gives the buyer whatever stock they want to buy, correct? There's a market, but there's buyers, there's sellers. Well, right now, technically, there's even no sellers. So how can there be buyers? If this is not there, how can you have a buyer? This is where liquidity pools come in. So liquidity pool it's a pool of money basically that you put in. And this pool has money that you put in which has value, like for example, Ethereum, okay? And your coin, let's just say it's your W3 coin. And what you're doing is you're putting 100 ETH, let's say you have 100 ETH for 100 W3 tokens. That means one token cost, one W3 is equal to what? 1 ETH. Does not have to be necessarily the case. You can also say 100 ETH is 1,000, 1,000 tokens, 5,000 tokens, whatever it might be. And so because now we put in 100 ETH and with 100 W3 tokens, that means a buyer can later on come in and say, hey, I want to trade now 2 ETH to get 2 WE tokens. Or W3 tokens, sorry. You can do that because you've put in 100 ETH. So he's not going to buy your W3 tokens in exchange for what? For 2 ETH. And so now the pool is going to have 102 ETH, but W3 tokens is going to be a lot less of W3 tokens now because he bought that from the pool. The pool is there as a starting price. The pool is there as a way to start the bidding, as a way to start the market. At some point, when enough people have your W3 coin, then people start selling, buying, selling, buying, selling, buying, and then you have a market, and hence the price goes up and down and up and down and up and down because different people will want to sell at different prices. Let's go ahead and now add our liquidity using something called PancakeSwap. Go to Google and type in PancakeSwap. Pancake Swap right here. Click on that one and make sure you select the Ethereum network. That's the one we're going to be using. And then just hit the connect wallet. Select your MetaMask and select the account that has your coins, the new coin that you created. Okay, so I'm going to be using my testing account. That's the one I used to create everything. And it's going to ask you to switch to Ethereum mainnet. Go ahead and switch that for now. Now we want to go back to our MetaMask and switch it now to Goerli. Just like that. There we go. And now you should see Goerli right here. Let's go ahead and try to swap our coin now. We're going to try and swap Goerli for some other token. Now, what other token it is, I import this W3 token. And the way you can do that is you can have this contract address, copy your contract address, and then you want to go ahead, paste in the contract address, and you will see your W3 token right here. And now if I try to, let's just say, swap 0.1, it says insufficient liquidity for this trade, as you see, because we don't have enough liquidity. There's no money in that coin in general. So let's go ahead and add the liquidity. Click on the liquidity section right here on the top. And you want to do add liquidity. And you'll notice here it says Goerli. And then what are we going to be adding? The W3 token. So select that one. Beautiful. You will notice here it says you are the first liquidity provider. The ratio of tokens you add will set the price for this pair. Once you're happy with the rate, click supply to preview. So let's go ahead and supply 0. Let's just say 1 Goerli for, let's just say 2,000 W3 tokens. 2,000, right? 2,000 W3 tokens. That makes the cost of Goerli per W3 around this. That's the cost of Goerli for W3 token, right? And then what you want to do, and then you want to set enable Web3. Let's go ahead and do that. Hit confirm. And now we're going to add liquidity. Now let's go and supply that 0.1 ETH to, for W3 tokens. Hit supply. There we go. We're going to supply 0.1 Goerli for this many W3 tokens. So I'm going to say create pair and supply. Now it does, unfortunately, cost quite a lot. You can see 0.4. So it's going to cost you some money. So you might have to get more money from the faucet. So let's go ahead and confirm. Beautiful. Transaction submitted. View on Etherscan. Let's see. It has been confirmed, my friends. And now you have liquidity. So hit close here for a second. But check this out now. Here's the cool part. Because you provided liquidity now, okay, because you have liquidity, and here it is liquidity, right? So it's you provided 0.1 ETH for 2,000 of W3 tokens. I can now go ahead and swap. So let's just say I want to use some of my Goerli ETH. You can see I still have 0.56. I want to get more W3 tokens. I can say Goerli. I'm going to say 0.001. And return is going to give me 19 W3 tokens. So you can see now a person can go ahead and actually buy W3 tokens because of the price that I set. I provided 0.1 ETH for 2,000 W3 tokens. It's now in the supply. For example, here, swap. Right, Goerli for W3 tokens, confirm swap, and then there we go. There's the cost, hit confirm, and I will now have more W3 tokens. And I should actually have W3 in my wallet already. Let me go on my assets here. There we go, 8,000. But since I bought more W3 tokens, I should now have more than 3,000. See, I have 8,019. This is how CryptoCoins, this is how coins get their value. Once you start up the whole coin situation, once you give liquidity and people start trading coins, this is where it gets really interesting, because this is where now the price will start to fluctuate, because now you have a seller who wants to sell for a certain price and I have a buyer who wants to buy for a certain price. And this is where now the price starts to fluctuate, and that creates a market. Hopefully you enjoyed this one. Don't forget to like, subscribe, do all the things. If you have any questions, leave them down in the comments below. Other than that, I'll see you later. Bye. Let's go ahead and now build a staking contract. Those of you who don't know what is a staking contract and why would you stake NFT, let me explain it to you. Let's say you have an NFT. This is your NFT. And let's just say there's a company that wants to give you a reward for not selling the NFT so that they can increase the price of the NFT in general. They do it by something called staking. What you do is you stake your NFT. What it does is it says, hey, I'm not going to sell. I'm going to transfer ownership to a contract for a certain amount of time. Let's just say for 5 months. Then you get some kind of a reward, which could be a token. And so why this is good is, one, for the company, they're happy because you're not selling your NFT, hence increasing the floor price of the project fully. And then you are happy as well because you get money. So it's a win-win-win situation. But how does this all work? So down below in the description, I have a GitHub link where you will be able to find the links to the staking contract. Go to the GitHub link, and all you have to do is simply download it, or honestly, you could just view it from here. And there's 3 parts to any staking contract. The first part, that's the NFT contract. The second part is the token reward. How are you going to be rewarded, and what money are you going to be rewarded? And finally, the third part, that's the staking contract. So there's 3 contracts that play into this. And the staking contract talks to both. It talks to the NFT contract, and it also talks to the token contract. And whenever you want to stake your NFT, the ownership of this NFT goes to another address. That way you don't have the ownership of it anymore, but as a result, you get a reward. Later on, let's just say you want to unstake. You can simply unstake your NFT, so you get your NFT back, and you get a reward depending on how much you staked it for. And a lot of projects actually do this. You're talking Bored Ape does this, and so many other companies, that by staking your NFT, you actually get a reward as a result. Pretty cool. If we look at our contracts, there's 3 contracts that we are technically working with, and these are the ones right here. There's the Web3 token, the Web3 builders, and the Stake.sol. You, for now, are going to be looking into this one, onto these 2. This one, we're going to be building together. So let's go ahead and go to Remix IDE, and let's start with our project. So I have a few different workspaces. You want to create your own workspace for the staking contract. And so to do that, just hit plus right here. And then let's go ahead and call our workspace. And this will be stake ERC 721, and hit OK. And there we go. And now you got the contracts folder, the scripts folder, the test folder, and we're going to be working inside the contract folder. Now what I want you guys to do is go to the contracts section, right click, new file. Let's create a Web3 builders NFT.sol. This is going to be our NFT contract. Let's go back to our GitHub now and go into the staking folder on GitHub. Go into the Web3 builders ERC 721.sol and just make a quick copy right here. Paste it in, save it, and you should be all good. So hopefully, let it compile. There we go, and we got a green check mark. At this point, that's it. You don't have to worry about anything because the goal here is not to teach you how to make an NFT contract, it's how to make a staking contract. The next thing we're going to do is create the token contract, the reward token contract, which will be used by the staking contract. We'll right click on the contract and hit new file and call it Web3 builders token.sol. There we go. And let's make sure, and we need to copy and paste the token itself. So let's go back into our staking section. Let's go to web3.token.sol. It's pretty short one. Tokens, ERC20 tokens are pretty short most of the time. And let's just paste it in. Hopefully you should have this. And for those of you who don't know, what happens here is we are actually minting 10,000 tokens right away to you, to the person who's going to be deploying this contract. The last thing that we're going to be creating is now the staking contract. So let's right click and hit new file and create web3 staking.sol. Okay. Now, this is where you and I are going to be working together now to figure this out. What is in the staking contract? What we know is the staking contract is going to take both the NFT token and the ERC20 token, and then it should allow you to give you a reward and stake your NFT. Let's start out with your normal SPDX license. There we go. This is going to tell that this is MIT license. Let's go ahead now add our Pragma Solidity 0.8.4. After this one, let's create our contract. We'll say contract here, staking. And this is where all the logic will go. The first 2 things we need to do is think about this. We're going to be talking to 2 different contracts. We're going to be talking both to our ERC 721 and to our ERC20 token reward. The way we need to do that is we need to import those contracts into our contract. So what we need to do is we need to import the ERC 721 implementation from OpenZeppelin, And we also need to import the implementation of ERC20 as well. Now, this will be important because now check this out. The way you talk to other contracts is by using their implementation. I will say this, ERC20, and I'm gonna call this the token. Basically, think of it as like a class. Let's also create our IERC 721 as well, IERC 721, and that's going to be the NFT. Now, one other thing we're going to add to this, I'm going to say immutable, meaning it cannot be changeable. Immutable. There we go. Immutable means they can only be assigned once. And where they need to be assigned is inside the constructor. So we need to create the constructor now. In the constructor, there's going to be two parameters that we need to add. One is going to be the address for the NFT. So address, and that's going to be the NFT. And the other one is going to be the address for the token. It's actually a really cool rule to follow is that when you're passing parameters, you actually want to use underscore for parameters. You can say now, hey, NFT is equal to IERC 721 and pass in the contract, the underscore NFT contract. The same thing is going to happen for the token. We're going to say token is equal to IERC 20. There we go. I'm going to pass in the token contract address. There we go. And that's it. And what you have done is you've made a connection to both the NFT contract and the token contract. Let's now create the staking function. Create a function here called stake. And we are going to pass in one variable, and that's going to be called the token ID. What ID do you want to stake your NFT? So we say, hey, you went 256, and it's going to be underscore token ID. This is going to be a public function, and it's not really going to return anything because it just does stuff. The first thing when we stake is when you try to stake your NFT, you have to know that you got to be the owner. The person who's also staking needs to also be the owner of that specific NFT. So we need to check that. So we say require, and inside here, we can check this out. We can reference back the NFT objects. We say NFT dot owner of, and where that's coming from is from the actual ERC 721 implementation. Token ID needs to be equal to whoever the caller is. Message.sender. Otherwise, we say you don't own this NFT. And again, it's going to be underscore token ID right here. This right here is the interface for ERC 721. And so if you notice the interface for ERC 721, which gives us basically the interface for what functions we can use in the contract, and owner of is one of them. And owner of simply says, hey, who's the owner of this token ID? And that's what we did here. We're checking, hey, if the owner token ID is the same one as the caller, then we're good. Otherwise, you are not the owner. Once we have that, we need to now stake the NFT. How do we stake it? Or we need to have some kind of a data on how we save it. So we're going to create a mapping between the address, an address of a user to another mapping, and I will explain how this works out here in a second, to another mapping between a token ID, so UNT256, to something called a timestamp. And that's also going to be a UNT256. And you want to call this to be a public and call it stakes. Boom. And the way this works is we're going to save, let's say this is you and you are the address. So you have some kind of address 0x00 something. You want to stake your NFT. In the mapping, it's going to be your address mapped to an NFT ID, which could be like 1 or 2 or 3. So whatever the token ID is. So it could be like 0, let's just say. And that is mapped to what timestamp you staked it. So it could be like 1, 2, 3. It could be, it's a timestamp of the exact time and when you staked it. Now, let's just say you stake another NFT. So there you go, stake NFT 1. That's another times 2, 3, 4, 5, 6, whatever it might be. Again, timestamp of the current time that you are staking the NFT and so forth. And why this is cool is because later on, we will use this timestamp to figure out, hey, how much time has passed between then and now, and then we'll know how much reward to give you. Hopefully that makes sense. And now what we want to do, since we already checked, hey, you're the owner, we can now say stakes at the message.sender. So whoever sender is. And then because we're mapping to another mapping, we're going to specify the token ID. So again, we're creating this data point is equal to what? The current timestamp, block.timestamp. Once we save this stake information, what you want to do now is send over this contract. So you have this NFT, and currently you are the owner of this NFT. When you stake it, you are given the ownership to someone else temporarily, in which case it's going to be the staking contract. The contract is going to be the owner of your NFT temporarily for a certain amount of time. So how do we make that happen? Is pretty simple. We will now use the NFT contract we set up before, and we say NFT dot save transfer from what? From message.sender to the address of this contract. Address of this address. What token ID? Underscore token ID. That's the token ID we're trying to send. And the data, don't worry about the data. That could be nothing. So we're now transferring that specific NFT. Once you've transferred it, that means, okay, it's no longer yours. And so that's it. You went ahead and you stake the NFT. You've saved the data. You've transferred it. And that's pretty much all you have to do. Now, the next function we're going to create is the onStake function. So let's go ahead and function on stake. Okay. Again, I'm going to pass in the uint256. So whatever token ID you want to pass in. That's also going to be a public function. And this is where we are now going to be unstaking it. We need to calculate reward for whatever it is. We need to transfer the NFT back to you, back to the original owner. And then, of course, send the reward. There we go. First things first, we need to calculate the reward. Let's create a function here called calculate reward. Function calculate reward. We can do it inside here, but I just to keep it cleaner, I'm going to do it in a separate function, okay? Same thing for this one. Pass in the uint256. Let's go and type this out. uint256. This gives the token ID. And this will be a public view function, because it does not change anything. Just simply recalculate some data and returns it. This will return for you the total rewards. uint256 reward. So we got the calculate reward. Let's actually calculate it now. First, let's calculate how much time has elapsed between you staking the NFT and then between actually you unstaking the NFT. So let's figure that out. We say uint256 time is equal to, and how do we get the current timestamps? We say block.timestamp minus stakes. Okay. We say message.sender and token ID of this one, token ID. Now, to calculate the reward, we do actually want to make sure that you staked the reward. So we want to do a require. We want to say stakes at message.sender at the token ID underscore token ID has to be greater than 0, meaning at this position, remember this value says what? The timestamp of when you staked it, and technically if there's no value, then it's technically 0, so we want to make sure that the timestamp is greater than 0. Otherwise, we say NFT has not been staked. Now let's calculate the reward, and we want to say uint256 reward is equal to what? And this is where it becomes interesting, my friend, because we need to figure out based on how much time. So if you staked it, let's just say for 1 month, you should get a multiplier of, let's just say 1. If you staked it for 2 months, your multiplier could be 2. So we're going to create a calculate rate function here at the top. Let's say function calculate rate. We're going to pass in the time, which is how much time has elapsed already. And here's the cool way to check. Hey, let's just say we want to check if you've staked it for less than 1 minute, then the multiplier will be 0. We say if that time, which again, the time is what? The time is how much time has elapsed between now and then. If the time is less than 1 minute, then we're going to return, let's just say 0. Meaning the multiplier is 0, meaning whatever reward you're trying to get, it's going to be always 0. Else, if time is less than 3 minutes, then we're going to return, let's just say maybe 3. Else, if, there we go, time is less than 5 minutes, we're going to return then 5 maybe. Otherwise, if you do more than 5 minutes, then you will get the full thing, which could be like 10. Again, this all depends on what the company wants, what the project wants. So we're calculating this rate. Let's now actually call this function inside our calculate reward. Call that function calculate rate. Let's paste in the time. So we're going to say the time. And we need to multiply this by the time. And then we need to multiply it by 10 to the 18th power. Here's why, you guys. Because the 10 to 18th power, that's how many decimals we have in the token. So let's say you have this calculate rate. Let's give it a 3. The time, let's go ahead and maybe give it a 3 as well. When you multiply this, you get, let's just say 6, okay? Now, if you try to give 6 as a reward, that's a small token. Because if you think about it, when you send over money through blockchain, you're not sending over 6 ETH, for example. No, you're actually sending over 6,000,000,000 way. That's right, way. This is the lowest denominator of ETH. It's the same thing as saying $1 is equal to 100 cents. So it's the same situation. 1 ETH is equal to 1,000,001 to the 18th power in way is what they call it. So when we send over money through blockchain, we're actually sending it in something called way. And when you have your own CryptoCoin, so it is to the 18th power. So 6 to the 18th power is actually 6, let's just say, whole tokens that you might want to send to people. So that's something I want you guys to understand, is that's how you actually send over money. Now, we're not done yet, because now we need to divide this. We multiply this, we get the actual amount of reward, but this time is really huge, because this time is a number. This time is literally like 5, 3, 6, 6, 7, blah, 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 3, 4, 2, 1. This is a really big number, okay? Because this is a timestamp. And so what you need to do is you need to divide this by another timestamp, which represents 1 minute. 1 minute. 1 minute is a timestamp. Let's just say it could be 5, 3, 4, 2, 1. If you take this number, you divide this number, it gives you a whole number of whatever something is. To give you a metaphor, it's the same thing as we all know, there's 24 hours in a day. So let's just say that you have 72 hours that went by. How many days is that? How many days is that? You got to divide this by 24 hours. That is what is equivalent to 1 day. So if you do 72 divided by 24, that gives you 3 days, and that is the exact number that you're looking for. The same thing happens for time as well. We're dividing everything by 1 minute because we're trying to figure out how many minutes are in this little timestamp. Hopefully that makes sense. Basically, what we want to do now is divide this by 1 minute, and this will give us the full reward. Now, very important, do not forget to add a returns. For the type of a function, we want to set this to private, pure, and then returns. Returns uint to 8. So again, it's going to return a small number, which is what this is, 0 or 3 or 5 or 10. Okay, oh, private. I misspelled private here. There we go. And this should be all good. So you've got the reward. Now what you want to do is simply return it. Just return the reward. And that's going to be the reward that the person will get at the end of the day. So right now it's giving you a small little error because of the naming here, which is similar. You can just remove this reward section and just say, hey, it returns a uint56, and you should be all good at this point. So we've calculated our reward. We have calculated our rate of rewarding as well. At this point, we just want to unstake. We want to call the function for the reward. So you want to say uint 256, right? Reward is equal to what? Is equal to calculate reward. And of course, we want to pass in the token ID. Then we're going to delete the stakes. So delete stakes, because why? We are going to return it, and now we're going to need to delete what? Delete the staking, which is remove the data from here. Okay, delete stakes. Let's say message.sender, sender at what? At the token ID that we passed in. And that's it. So it's going to delete that data. Right? At this point, let's transfer the NFT back to the original owner. NFT dot what? Save transfer from address, from this address, because that's what will be transferred, to who? To back to the user, which is message.sender. Sender. And the token ID is going to be the underscore token ID, and the data is going to be nothing. We're just going to say here. There we go. Once we've transferred it, we're going to now give them money. Let's just go ahead and say token.transfer. And to who? To message.sender. And how much amount? The reward amount. And that's it, my friends. And that's it. We're pretty much done. We have the unstake feature. We have the stake feature. And again, this is the simplest staking, unstaking. Of course, you can make it more complicated. You can add a lot of different features, different tokens, different reasons, and different ways of rewarding people, and different attributes of how you reward people. There's different ways of going about this. But at the end of the day, this right here is probably the simplest way of doing this. So I just wanted to show you. So at this point, you should be all good. Now, of course, you want to be able to test this. And the testing is where it gets a little bit tricky, because blockchain just sometimes does not make it easy for us. So I'm going to teach you now how to create your own test network, your own blockchain, using something called Ganache. So check it out. Let's go ahead and go to Ganache here. Ganache. And say download Ganache Ethereum. Then again, the links will probably be somewhere in GitHub. If you look at it here, there's your install Ganache. You can just click on that link and then you're pretty much all good and dandy. Ganache Truffle Suite. There we go. Download this. So I already had this downloaded, but download this for yourself and then just install it. In the meantime, while it's downloading, I want you to open up these 3 different contracts in 3 different remix files. You'll see what I mean why. Open up a new remix IDE. Let's go and open up the Web3 Builders NFT inside this one. So we'll just keep this one open up. Then we're going to open up another Ethereum IDE, and that's going to be for the ERC20 token. Again, remix IDE, mainly because it's going to make it easier for us to move around when we do this kind of stuff. Go to the contract, and then this time open up the token, all right? We need to now launch all these tokens on the blockchain. Let's go back to our Ganache here. I have my Ganache. When you open it up, and all you gotta do is just transfer Ganache into the application. I'm excited. This is a really cool contract. It involves 3 different contracts. It's very different than your normal ERC 721 because you're talking to different contracts and you're making sure that all that works together. Let's go ahead and open up our Ganache. Should be somewhere in your applications folder. Where's my Ganache? It's so funny. Ganache is actually dessert. There we go. There's a Ganache. Verifying Ganache. Hit open. And my friends, there we go. There's our Ganache, you guys, okay? This is going to be your local blockchain where you don't have to get any test tokens. You don't have to figure out where to get them. Just make it 10 times easier for you. Let's go ahead and do quick start Ethereum because that's all we need. And notice this number right here, this HTTP request RPC server, that's going to be 7545 as you can see in the end. And there you go. These are all your wallet addresses and each of them have 100 ETH. Yeah. You're rich. So at this point, let's go ahead and just remember this 57545. Put this to the side for a second here. Let's go back to our contract. I wanted to launch this on Ganache right now. So we want to go into this section where we actually deploy our contract. And in an environment, you need to change some stuff. Instead of saying remix merge, you say dev Ganache provider right here. Click on this one. And change this number to be 7545. Again, depends on what it says here. For me, it says 7545. It might say 8545 for you. And then you should be good at that point. Hit OK. And there you go. You were connected to your own local blockchain. And here's your F37C2. And you'll notice these are all your wallet addresses, similar to the ones that you have in Ganache. F37C2. So these ones, they directly correlate to what you have. So let's go ahead and deploy our NFT contract first. Here's our NFT contract, the ERC 721. All we gotta do now is just simply deploy it. Again, so make sure you have Ganache selected and hit deploy. And then let's see what happens. Boom! You got yourself a smart contract. There we go, my friends. And if you look at Ganache, just to show you here, you can look at transactions. You'll see the transaction actually happen. It says contract creation. That's the cool thing about having something like Ganache because you will see what's going on. You will see exactly what transactions are happening and just like you would on a blockchain. The next one we want to deploy is going to be our ERC20 token. So let's go to our ERC20 token. That's going to be our next remix IDE. So here it is, web3builders.token.sol right there. So make sure that one is selected. Go to deployment section. Double check this section. Make sure this is selected. The Web3 Builders token is selected, this token. And let's go ahead and change this to be, again, the Ganache provider. Change this to be 7545. Hit OK. And just hit deploy. There we go. If you hit this little arrow icon, this little cute arrow icon, it will actually expand everything for you, and this will show you. At the same time, you're also minting 10,000 tokens towards yourself, so just remember that one as well. Now, we need to deploy the staking contract. Now, the staking contract is a little bit more difficult because it involves both the NFT and the token. So select the staking contract. There it is. Select the deployment. So go to the deployment section right here. In an environment, let's change that to be Ganache. Make this dev Ganache provider. Change it to be 7545. Hit OK. In the deployment, you see this deployment button. Click on this little arrow icon. Click on that. And here you provide the NFT address and the token address. So NFT address, that's the address to your NFT contract. And where is that at? That is, let me look at my remix. That is here. So you says Web3 Builders. There is our NFT. Click on this one to copy this, paste that in, and that's your address. For the token, do the same thing. Go to the token, copy that from the Web3 token, okay? And then paste that token address in as well. And just simply hit transact. And there you go. You have created your staking contract. And there's 4 functions: stake, unstake, calculate rewards, and stakes. Simple as that. Now, in order for you to stake an NFT, what needs to happen? You need to be an owner of an NFT. And right now, if I try to stake, let's just say, an NFT ID of 0, I should get an error that says invalid token ID, because why? We have not bought this NFT. So now we need to go back to our ERC 721 contract, which is what this one is. And we need to mint an NFT for ourselves. And again, we're all using the same wallet address, this F37C2 for all 3 contracts. Okay, this is why we're able to do this. For the edit mint windows, you want to set those to be true for all of it so that we can mint, public mint, and allowlist mint, and just hit transact. Done. Public mint, if you try to hit that now, you can see it says an error because not enough funds, because now you need to pass in funds of 0.01 ETH. Let's go ahead and go to our handy dandy Ethereum unit converter. Click on this one. Oops, I don't want that one. Click on it, hit 0.01, copy this GUI, go back to our contract, paste that into the value section, scroll down, and then hit public mint. Boom. And that should give you a green check mark for you to public mint. And you'll notice now if you do total supply, it says 1. Let's mint a few. So I'm going to say value again. I'm going to paste in that specific number, that number, 1 trillion, 1 billion, I don't know, GUI. Hit public mint again, and now I minted 2 NFTs. Let's do it one more time. Public mint again, and now I have 3 NFTs. And if we go total supply, we have 3 NFTs right here. Let's see what happens if you try to stake the NFT now. So let's go ahead and hit stake. Okay, since you're not the owner, you should be able to mint. So hit transact. Put in 0. Hit transact. Oh, look at that. Caller is not token owner or approved. Interesting. Why is it the case? Because you need to now approve your staking contract to transfer the NFT. I know. That's how OpenSea does as well. You give it approval to do it. So hit cancel this one. Go back to your ERC 721. This is why I said we need to create 3 different tabs. Go back to your ERC 721 and approve your staking contract. You see this too? So take your staking address, this is right here. It says staking at this address, and just copy that. Copy it. Paste that in, and token ID say 0. Let's just say you're approving the transfer of token ID of 0 to this contract, and hit transact. Now if you try to stake again, try it one more time here, transact. Now we get an error, and the reason for that is because we need to implement this ERC 721 receiver. If we're trying to transfer an NFT to you, then you have to have an interface that supports the transfer of that NFT. And that's what this ERC 721 receiver is for. And it simply just implements a function that allows you to receive an NFT. So to import it, all we gotta do is go all the way to the top here on line 7 and simply just import the receiver token ERC 721 ERC 721 receiver.sol. After you imported it, the ERC 721 receiver, you have to make it as part of your contract. So for the staking say, you want to say is ERC 721 receiver. So that will allow you to basically import it. And now we get an error yet again. Boo! Yes. Why that's the case is because if we look at the code, and again, I'm going very detailed because I want you guys to know. If you look at the code of ERC 721 receiver, it's an interface. It's an interface where this function gets called, but there's really nothing inside this. An interface has no content inside this function. And so what happens is saying, hey, you need to actually implement this function. Okay, you got this ERC 721 receiver. Great, you can now receive NFTs. That's awesome. But it says missing implementation, which is exactly what it is. We need to implement that function. And where can we implement it from? It's from something called ERC 721 holder. So let me show you here, ERC 721 holder. And there we go, my friends. It implements the what? The ERC 721 receiver interface. That's it. So it accepts all token transfers into your contract. That's the goal of this specific little function. Okay, just remember that utils ERC 721 holder. That means we need to also import this into our contract. So let's go ahead and do that right now. There we go. Let's go ahead and import into our contract. Hit import ERC 721 holder. Hit comma. And then we want to say ERC 721 holder. And that's it, my friends. and you've implemented the ERC721 receiver, you've implemented the ERC721 holder, and now you should be good to actually transfer NFTs into your own contract. Let's go back now and remove that contract you had before because we need to redo this anyways. So let's go ahead and do that. So again, we need to showcase the NFT and the token. For the NFT, copy the address from the NFT right here. We're so close, you guys. For the token, copy the token. There you go, Web3 token, paste that in and hit transact. Let's hopefully it works. It says pending. Beautiful, we've got our NFT. There it is. Again, if you try to now stake it, it will stay still nothing. You need to approve who's going to be transferring your NFTs every time. That makes sense, of course. So make sure you copy your staking contract, which is D1A43. I'm going to copy that. Go back to my Web3 Builders contract and just hit approve. There we go. Token ID of 0. Hit transact. And now it's been approved. And now, finally, the time has come, my friends. The time to actually transfer and stake your NFT. Okay. For this one, hit 0. Hit transact. Hey, we staked it. And you don't really see it, but check it out. We can check our address, our contract address in the stakes function. So the contract address that we are staked it is this one, F37C2. Yours is probably a little bit different here. So let's check our contract address. Let's check our token ID of 0. And let's say if it's staked. Indeed, it is. And this is our timestamp for when we staked it. So there we go. Now you've actually transferred NFT. And you can check who's the owner of your NFT. The owner of this NFT of 0 is no longer you. No, it's no longer you. It's now the contract. Let's check it. So if we go to our smart contract now, and we go to the owner of function, where is our owner of function? Type in 0, and look at this. The owner of this is who? It's not this, because you were the owner before, F37C2. No, it is now who? The A44A3, which is the staking contract. 1483 exactly. So you see how that works together. I find that to be so interesting and so cool personally. Now at this point, let's calculate our rewards. We type in 0 to calculate reward. We get nothing. We get nothing, unfortunately. Reason being, guys, is we have to stake something again because we're using the blockchain with Ganache. There's no new block created, hence the time step is still the same. So you can wait for a long time, but if you don't create a new transaction, there's no new timestamp. Make sense? So we need to create a new stake. So let's do that right now. Let's go ahead and stake another NFT. That means we need to approve it. So we need to approve the using of this NFT of 1, let's just say, and hit transact. So we've approved the staking of NFT of 1. Let's stake NFT of 1 at this point. There's my stake. Hit transact. There we go. It's staked. And now, because we've staked it, we have a new timestamp. We have a new block. If you look at our Ganache here, you can see we have a new block. We have a new block number 16 that was created, and we can have a new transaction. This is a contract call for staking the NFT. Let's go back to here. At this point, let's calculate our rewards. Hey, would you look at that? And if you don't know how much exactly that is in tokens, just take this number and divide it by the 10 to the power of 18, okay? There we go. Take this number, divide it by power 18, 6.9 tokens. So 6.9 tokens of that is how much is going to be transferred back to the user who staked the NFT. And how do we do that? To transfer those tokens, we simply just have to unstake it. So right now, let's go ahead and check our unstake function. So let's try to unstake it. So I'm going to try unstake number 0. We're going to get a few errors, guys, okay? I unstake at 0, 1. Transfer amount exceeds balance. Why? Because you're trying to send a reward to someone, which is me, the person who staked the NFT, but yet you got no money in the contract. That ERC20 token does not exist in your contract. We're going to go back to our ERC20 token now, the Web3 token, and we're going to give the Web3 token some money. And all I'm going to do, since I have 10,000 tokens because they were minted to me, the person who created the contract, the person who deployed the contract, I can transfer my tokens to this contract. So let's do that right now. So we'll say to the contract address of the staking contract amount. Again, this is not 100 tokens. It's 100 to the power of 10 to the 18. So I'm going to say 100 times 10 to the power of 18. Power of 18. It's a very large number. So again, it's 1 to the power of 20, right? So that means we need 20 zeros. So 1 20 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There we go. That's 100 of those tokens will go directly to here. So we can check that one more time. This divided by 10 to the 18th power is 100 tokens. Shall we do maybe like 1,000 tokens? Let's just do like one more. There we go, 1,000 tokens, because why not? And let's transfer those tokens. So hit transfer. There we go. And now that contract has a balance. So if we go back to our staking contract, there we go. We copy this staking contract and we're going to check the balance of this contract. So we say balance off for this address. There we go. So you can see it has money. As a result, it can now send money. So let's go ahead and do a unstake feature. So let's go ahead unstake 0, hit transact. There we go. You've unstaked this amount of money and you've sent money. And now you will notice actually that you are no longer the owner of the NFT. When you unstaked it, you no longer will be the owner of the NFT. Instead, the original owner is. So let's go to the owner of 0. Pay attention. This was the contract. Who was the owner before when we staked it? Since we unstaked it now, hit call, boom, the original owner is back. As you can see, the original owner who minted the NFT has now the ownership back. And now as well, you will notice who has the money now. You will notice that before the contract had this much money, but because we're giving back a reward, it should have less money. So if I call this again, it now has less money. And that money went back to the owner of the NFT, the person who staked it. And so there you go. There is your staking contract. How cool is that? You've learned how to stake, how to unstake. You've learned how to create 3 different contracts, the 721, the ERC20, how they all work together, how to approve the transaction, the transfer transaction, all of it. Very exciting stuff. You can now take this knowledge and take it to another project, do it for yourself, for your own project, and so much more. But that's pretty much it. Hope you guys enjoyed this. If you have any questions, let me know down in the comments below. Other than that, don't forget to hit like, subscribe. If you want to see more videos like this, I always, as always, really appreciate it. I'll see you guys later. Bye. I love you. Peace out. Let's go.